Hello, hello, and welcome back to the more technical portion of the workshop. How are people feeling after lunch? Are you revitalized and energized? All right, cool. Would people prefer to, because I'm going to do an overview of what the menu of options are right now. We have a more in-depth architectural overview of Sapio. We have some content on what Manuscript is as well, and a Rust programming guide. And then we also have a tutorial for getting set up with Sapio. I was thinking we would end with the tutorial on getting set up, unless anybody feels strongly that they want to, play around and that's going to be the best way for them to learn. Does anybody feel strongly that they want to be set up with Sapio right now? All right.
Can I request, this is from an anonymous audience member, could you just say exactly what CTV is?
Yeah, there's a whole presentation on that coming up. Yeah. All right. So all of the slides are in this Unchained presentation. At the end, the last slide sort of has a link tree of sorts. Buck is about to rename all of those to the appropriate name so that it's less confusing of which one to click on. Thank you, Buck, for your service. Without further ado, we're going to start with, as I said, somebody wanted a little bit more of an overview. We're going to talk about the architecture of Sapio under the hood a little bit, and really like this theoretical calculus of covenants thing. Then we're going to do a bit on what actually is CTV in this context. Following that, we will do some content on what Manuscript is and how you can use that, and we'll play around with that a little bit. And then lastly, we'll just do a little bit of a primer. Who here has done any Rust programming ever? So some people have played around with it. We're gonna do a little bit of a primer that's just building some intuition for things you'll see in Rust that will help you as you try to program in Rust, avoid a lot of the common pitfalls people hit. And that should hopefully help when you're looking at some of these samples of code of how you can get the compiler to stop fighting you. And then we will delve into getting Sapio set up, and then hopefully we'll have time for people to attempt a small challenge that I've set up. That should be a lot of fun, but we may run out of time. So we'll see if we can get there. So kicking off, we're going to jump into the Sapio architectural overview. What is Sapio? So it's just like Solidity. Not really, but it's kind of similar. It's a high-level language for writing smart contracts. It has some nice tooling. You can accomplish a lot in it, but it's not targeting the EVM. It's targeting Bitcoin. The Bitcoin VM is this concept that I made up, but actually Satoshi made it up. But there's not really been a really strong formal model for what this Bitcoin VM is. It's just sort of oh, well, there's transactions and then there's scripts. But maybe we can think about this in a new theoretical way, and that's going to yield some better mental models for how we should think about smart contracts. So a common misconception is that Sapio is uniquely for CTV. And this is kind of a little bit of a misunderstanding, because Sapio is really trying to target any arbitrary transaction graph. And if you can target an arbitrary transaction graph, you can kind of target any type of covenant. And inside of Sapio, because CTV is a concrete, well-defined thing, we can add special support for what CTV can do inside of Sapio. And if we had other concrete covenants, we could add special support for what they do inside of that framework. But we don't have any other covenants right now that are generally available if we had such things, or if like people on Liquid wanted to, make Liquid Sapio compatible, like they could probably do these things. If, Blockstream wants to write me a big check to like hire people to work on it, like, sure. Do you have a question?
Yeah, when you say concrete and well-defined, are you referring to anything in particular, I guess, in relation to those characteristics of the smart contract?
Well, what I mean is that like there is code for it, and the code like has been like tested like pretty thoroughly, and there are tools that you can use that like you can work with it in terms of like Manuscript and other things. And so like it's not just like, hey, here's an opcode, figure out how to use it. It's like, kind of well formed, and we'll talk about the theoretical properties and why those are important kind of over the next two presentations, because any other covenant proposal would have to have that well-formedness as well to be integrated. So really, Sapio could model any kind of covenant system with like multi-sigs, or like even like Lightning can be thought of this. And there's a spec in one of the Sapio examples of like, if we had any prev out, you can actually implement like L2 inside of Sapio. And so I think we don't have any prev out, so it doesn't really exist actually, but like Sapio has one of, the any prev out L2 Lightning implementations, because you can model that type of state transition system. So it's kind of cool. I wouldn't use that in production, but it exists. So it's not quite a standard, but it kind of is a standard for making Bitcoin transaction flows. And one day I would aspire for Sapio to, grow up and leave the house and, become something that there's maybe a standards body around, so that I don't just get to like, rug pull everybody when I get a new crazy idea, that it's something that people actually, across a wide variety of providers and users, you can rely on a sort of formal semantics of how these things should work. And then maybe we get even more better tooling around it and more standards for different types of like simps or, other metadata protocols, things like that. There's a lot of stuff that I showed you today. And here's kind of the architecture diagram. And we'll start from the top up, or top down, which is that you have some Sapio application. So that's something like a vault or an NFT, something that you can interact with and see. It's a compiled module. And underneath that, you have the GUI layer. So there's the Sapio Studio React, which is like just like a pure front end. And then you have Sapio Studio Electron, which is kind of like the back end code for just running the application itself. And that back-end Electron application is actually using command line tools. It's architected that way, in particular with the Sapio CLI and Bitcoin so that any flow that you're doing that you would want to like automate one day or have as a part of actual like real infrastructure, it's not like there's like some special magical thing happening in like some mess of like JavaScript and TypeScript and stuff. It's mostly just shelling out to a command line interface, and you can re-implement using that. Maybe with relative ease. It still might be difficult, but it's doable, and you can have a separate tool that's managing these things. And then sort of on the other side, there's the Sapio language itself, which is a big block of complicated and nuanced topics and compiler logic and things like that. That is built on top of Rust Bitcoin, is like one of the main ecosystems, like that includes like things like Rust Manuscript as well. And then there's Wasmer, which is a WebAssembly runtime in Rust. There's Rust itself. Rust uses LLVM. Wasmer also uses some bit of LLVM for running WebAssembly. I don't really fully understand that, and if anybody else does, I'd love to understand more of how this crane lift thing works or whatever you end up using in the back end. But in theory, it's deterministic-ish, so probably good enough. And then after that, you got the turtles that all of this is based on anyways. And I don't think it's really relevant to talk about what those turtles are. Does anybody have any questions about this architecture diagram overall and like how the pieces kind of operate together? Did this make anything like more clear for anyone? Okay.
Actually, yeah. What exactly is the React library doing? Like, yeah, what exactly is the React library doing?
You weren't here this morning, right? Okay, so what you missed is Like there's like a full featured like graphical interface, and it's not really a library as much as it's a UI. Yeah, and I think you can see how much time I was spending last night working on this for y'all. There's a little bit of proof of work for you. But I think, let me see if I can pull up an interesting example here. I'm trying to remember what it's called, or what time it would have been at. Maybe 10:19. Yeah, I guess that's good enough. So there's just like a lot of things that it like handles in terms of being able to like, click on things and like generate the state transitions. All of this can happen in a pure backend context. There's nothing like super special happening. It just like happens to be doing the things that you need it to do in an interactive way. So yeah, people this morning got to see a pretty extended demo that will be recorded and available in some context. I don't know exactly. Any other questions to that? All right, cool. So we handled this. Nobody seems to be more confused. Is anybody more confused? All right, cool. We did some progress. So if you are more confused and don't want to say it, like, at the end of the day, what you need to know is you write a smart contract in this Rust embedded domain-specific language. That's called Sapio. That language, it's kind of like, has anybody ever like looked at like TensorFlow? Like TensorFlow is kind of a little bit of a language itself, right? And then what it does is it compiles a neural network for you. But TensorFlow itself is not really like that neural network. It's kind of like there's like this little in-between layer, and Sapio is kind of similar to that. It's a library ultimately, but really it's a language for describing flows of Bitcoin. And when you write a Sapio program, it's really making itself a little compiler that you can then pass a language, and the language is just a set of arguments to it, and it will generate an actual concrete program for you. And the Sapio module that you're running is not the actual transactions. The transactions are the compiled output, but Sapio is the thing that generates, the compiler that generates the transactions, if that makes sense. Those modules that you compile are compiled into WebAssembly. That's something that probably there's a little bit of room for improvement. Like I think there's some specs that people are working on for like, very, very deterministic WebAssembly. WebAssembly has a couple holes in how it's set up that you can, floating point numbers are, I think, unspecified behavior, but it is defined or something like that. And so you can get a couple weird things like that, but generally it's deterministic. So if you run a contract once, you run it again, you're gonna get the same result. It speaks, kind of natively, these modules speak JSON. You can, ask it questions of like, hey, what thing are you? And it will send you back a JSON, and you can use like JSON schema to say, what things could I send to this that it would send me back something meaningful for? So it's kind of self-describing WebAssembly module. Oh, yeah, I can try. And then, yeah, let's see. All right, now I'm sharing screen again. Cool. So resume. And then what you do is you load the module into Sapio Studio, and then you can use it. So you can play around with the transactions. You build your contract, and it gets saved to disk, and you can have like a vault or whatever covenant you're using. So that's sort of like the user story at the end of the day. So I use this term on this last slide that like it generates a mutable transaction graph. It's sort of a little bit of a weird thing to say. What is a mutable transaction graph? Well, let's start with the idea of a contract called Pay My Friends. And in Pay My Friends, Alice wants to pay Bob and Carol an equal amount each, and then put the change back into the contract. And that's Alice's intent. How it's enforced is like a separate question. So what Alice will start with is a contract that looks like this. Alice pays an amount to Bob, an amount to Carol, and then the rest recursively into Pay My Friends. So whatever is left over is still locked in that same covenant. Sapio allows us to finish a computation and then later pick up where we left off and resume that computation. And so in this example, we can say Alice is paying an amount to Bob, an amount to Carol, the rest to pay my friends, and then we can pick it up where we left off and do pay my friends to amount 2 to Bob, amount 2 to Carol, rest to pay my friends. And so we could then apply that recursively. And Sapio is just a toolkit for being able to deterministically regenerate and inject. If you're a type theory person, this is kind of like an effect type system of sorts. You can inject and resume computations in this graph of things. And it's not like directly mutable, because you can always regenerate the exact same graph again in theory. But you're able to continue adding things at the leafs of this graph is sort of the theory.
So, remind me if I'm wrong, but in your versions of Sapio, you had a way of using pre-signed transactions as well, right? And in this context of this particular contract, you have the rest going to pay my friends, which is a recursive covenant. How would that work in the pre-signed regime?
So that goes back to this slide here, which is that that's wrong. So like Sapio is for CTV insofar as it supports the paradigm of CTV as like a first-class citizen. However, there are other things it can support as well. And in particular, the emulation of CTV would work for, I think there might be some issues with some of the recompilation of how that works, but those signatures that the Oracle is supposed to serve you are like deterministic, and you can also cache them once you've generated them. But when at the point where you do one of these continuations, like you've left the purview of emulating CTV, you're now doing something else. And so that's kind of the, a little bit of the story around that. I don't know if that's a satisfactory answer, but like CTV is just one of the things, and emulating CTV is sort of a facet of like how CTV works, but there are other ways to use Sapio as well. And we're talking at a higher level about covenants that, which you also, I think, missed in the morning, is that like covenants are just like a construct of something that can be enforced as a restriction on transfers that encapsulates also multisigs. Multisigs that have strict rules around what they're supposed to do are also a covenant. It's just in the same way like a covenant on like a real estate transaction is still a covenant. It's just not enforced by the Bitcoin blockchain. If that makes sense. So, does anybody else have any questions about this sort of mutable transaction graph thing? All right, cool. So, kind of related to what we were just saying, like what's actually enforcing the contract could be CTV, could be multisig. Maybe we come up with like some newfangled future covenant opcode, but in general, like Sapio is like reasoning about the graphs themselves and helping us do tooling in our infrastructure around that. And it could support a lot of different things within that framework. But those things would, like Sapio is happy to do it, but like those things would have to be somehow well-formed. And so how should we think about the shape of like what is a covenant? And I have a post on the mailing list that has like a little bit better of a formal treatment to this. But this is like at a high level what you would need to understand. There's like some things where like, you can kind of abstract and abstract and abstract, and then it's perfectly formal. But what you really need to know about this is that you have some sort of intent generator. And the intent generator would be something like, I would like to sell my NFT via this transaction. And there's some sort of set of these intents. Then you have an authorization verifier, which checks like, is the transfer T signed by some key? And that's what is being checked. And then you have some authorization prover, which is saying T is allowed because I generated a signature with K. And that's the thing that's generating the validity of this intent. And then there's sort of like this meta component, which the formal treatment does a better job with, which is like, well, what's the set of all possible conditions? And are all these conditions desirable? Have we excluded all undesirable conditions? Have we included all desired conditions? It's sort of like this bigger picture thing. And these things can also be thought of in a recursive context as well. Is that gibberish for anyone? Is anybody just like more lost? A little bit? Okay. Here? Yeah, so we're gonna, we loop around. So, we don't just say things once and then go all in. So imagine I have a vault V in a UTXO with...
Sorry, one last question about maybe this is self-evident, but I don't know, I think it might help. Like, why do we need that list? Like, what does that give us to think about covenants in that way?
Yeah, so basically, this is the set of things. So I guess like there's a couple different ways of framing it, and I'm not sure which the chicken and egg version of this is, but like this is kind of the set of things that you would need to have to like formally prove properties of a covenant's possible state transitions. If you don't have these things, you definitely can't prove like maybe not definitely, but like I'm pretty sure you can't prove a covenant correct. So if you can't prove a covenant correct, I would say it's probably no good. These also happen to coincide with the things that you would need to implement a piece of code for in order to be able to integrate this into Sapio. And so that's why I think there's like this good impedance match of like these properties of formally proving it are the same pieces of code that you would need to write. And maybe you don't need to write the code, but you need to prove that the code could be written in a reasonable way. And if you can't do that, then the thing is probably like difficult to actually build tooling around, difficult to actually use, and maybe shouldn't be done. And if you can't, for example, like prove the entire set of intents that are provable under the verifier that you generate, then maybe there's bad state transitions. And if you can't generate a verifier, then how are you going to translate that into script? And if you can't generate a prover, then how are you going to actually like play any of the transactions out? So it's you need this like dance of things. And it turns out that like expressing these things, like generally people want to live at the level of the intents. And then you want the authorizer and prover to be something that's automatically generated for you, to be the tightest possible ones. It's kind of like the intuition you want to have. Does that kind of make sense? Like you don't want to spend your time writing a verifier. You don't want to spend your time writing a prover. What you want is to define a set of intents that are valid, and then for both of those things to be automatically derived, and to have a proof that like it's total, essentially, that you've got full coverage. Does that make sense? Okay. Yeah, sure.
So it's the answer to this is probably, it depends on your risk profile or risk appetite. But in terms of the multi-sig case and what you just said in terms of 2 and 3, are there opinions you have in terms of key K? Like what type of multi-sig to make it a covenant?
Yeah, I mean, I think that it could really be, so let's talk not about literal keys, because musig is a thing, right? Threshold, frost, all those things are things. It's really about like, what's the set of people? And that depends per contract and per security assumption you want to have. I don't think I have it in these slides, but like I have it, I think, in the formal presentation that I give, which is like, there's sometimes you have a covenant where you can find a property where only one of the people needs to be honest for it to be correct. Like a pre-signed transaction, if you have a federation of n people and one of them is honest, then it's okay. And if you're trying to do a thing for only n people and you're one of the n signers, then you're probably all right. There are other times where if you need to generate a future state transition, then you would need a liveness assumption. So you need to say at least this many people will be around to sign, but then you may also need the cheating assumption of like, not this many people are evil and will break the covenant. So it's really application specific. There's not like a general, like 2 of 3 is good enough.
Does CPO have enough knowledge to like help the user of it in terms of what you just said and like?
No. Yeah, I mean, I think that you can write contracts that would fail to compile if you don't provide enough keys, for example. But there's no way that Sapio can know that those keys are the correct ones. You could have keys that like attest to one another, and you could do things like that. But like that's kind of like you're now inventing a new thing that's living inside of Sapio. So, thank you. I don't know if that does that.
Yeah.
Okay. Yeah. I mean, I think the reality is that like new paradigms will emerge. People will figure out things around this, but it's kind of a layer up from what's happening in Sapio. Okay. All right, here we go. So let's look at a really simple example. I have a vault V and a UTXO 10 coins. If I say I want to move it, I need to wait 10 days after I say that to move it. So I say, I want to move these coins, I got to wait 10 days. And if I say my distress word, the funds get sent to my mom. That's what I want. Who wants this kind of vault? Okay, people don't trust their mom with their coins, I guess. So that is noted. I won't, Mother's Day's coming up. So anyways, let's map it back to intent. So TX1 intent is begin to withdraw funds, but allow time for the below transactions. TX send to mom. Intent is to send funds to mom. TX move after maturity. Intent is to allow any transaction afterwards. Does anybody have any questions about those intents? Okay, cool, we're clear. Map it back. Authorization. TX1. Authorization is done, for example, via CTV pre-committed in script. That's YX. TX send to mom. Authorization is done via CTV pre-committed in script, right? That's kind of the same, right? So you can, after some amount of time, send it. TX move after maturity is done via time lock plus key sign, and that's an open-ended covenant, right? It says after this amount of time, send it wherever you like. Does that make sense? It's like now we have the, what's the authorization for any of these things? Cool. Lastly, verifier. TX1. Verifier checks that transaction hash matches. That's all the verifier logic has to be. Transaction sent to mom. Check the transaction hash matches. If you're using a CTV emulator, this would be like, check that the signature is from the oracle that you're using, for example. And then TX move after maturity, check the time lock, check the signature. Does that make sense? So that's an example of where we now have expressed the three facets of the intent, the authorizer, and the verifier logic. And all covenants look like this, when you zoom in, is that you have some sort of way of generating a state transition that you want. You need to prove that the state transition is correct, and you need to generate a verifier that accepts only those proofs for the state transition that you want. And if you can't do those three things, then you don't really have a covenant, do you? Like I don't see how what you're doing would be a covenant if you are missing any prong of these three things. Or maybe it would be a covenant, but it's not a well-formed covenant. It's kind of useless, right? Does anybody have like a counterexample that comes to mind? I mean, this is kind of like a new idea. This isn't something that that was handed to me on a tablet. It's just like, hey, I think that this is kind of the ground truth for these covenant things. Any covenant proposal should go through this gauntlet. So Sapio currently is solving this for a really small subset of circumstances. It solves it for check template verify, and it solves it for multi-sig E things. And it's kind of interesting because those are like two very opposite ends of the spectrum. One is really not too powerful, in theory. In practice, it's quite powerful. And the other is like the limit of power, right? So like, how is it that we have the limit of power and like the most restricted and nothing in between? Well, the meta-analysis for CTV is really easy. It's just like one single transaction. And there's some sort of calculus of like composing these things of like CTV covenant A in a tap leaf and then CTV covenant B in a tap leaf. It's kind of like the intersection of those properties, or maybe not intersection, whatever the set theory term is, the union of those properties. And then multi-signature is also really easy because as long as you define a good federation for your multi-signature, if the majority of those are running the same Sapio code, they will all be verifying the state transitions by seeing that they were constructible through the Sapio code itself. And so sort of the wisdom of this is that we're completely subverting having to have any of this happen as a consensus level authorizer or verifier because we're doing client-side validation for the covenant. And so when we jump to the client-side validated world, this is actually quite easy because Sapio is already doing the task of being both the intent generator, but also the prover and authorizer if we were to write our covenant in a way that we're happy with all the state transitions it can generate. Kind of a little bit of a weird thing because it's the middle part is the undefined area. So people don't like CTV. People also really like it, but there are people who don't like it. And my challenge for people who don't like it is just extend Sapio to support your covenant. I don't want to hear any debate. I don't want to hear any like, oh, this is better. Like, implement it so that we can use it. Like that I think that's a pretty straightforward ask. It might be a high bar, but the reality is like to do CTV and argue for CTV, I had to build all of Sapio. I am just asking you to build a plugin into Sapio for your new opcode. And it's not even like for all the uses of your opcode, as we talked about before. There's the opcode and the worst thing it can do, and there's the opcode and like one thing it can do in a well-formed way. Just implement it for the well-formed thing that you're trying to get it to do so that we can write applications around it. And if you can't do that, you know, like probably whatever you're doing like is an immature concept because we don't have an idea of how to write the 3 prongs that you need to have a covenant. So it's not usable, right? Like if it were usable, we would know how to write those things. And you don't have to do it in Sapio. You could do it somewhere else, but like you have to do those things somewhere. May as well do it in tooling that solves 99% of the other problems. So is this like a clear framework for people? Like, does it make sense of like where like maybe this is kind of like going to be the fertile ground for all covenants research? Does anybody like have a feeling that they would like not like to, if they had a new covenant idea, do it in Sapio? Is anybody like they'd do it a different way? So one example of something you could do instead would be to implement it in like Minsk. Do people know what Minsk is? So it's like an alternative tool chain for writing Manuscript things that recently has added CTV support. Nadav, also super smart guy. He won the PlebFi hackathon with a social recovery wallet that he did in Minsk, and with a clear line of like, we all know that he made Minsk, but he used it really well. So kudos to him. But like you could do it in another thing. Like I have no problem with that. Actually, one of the points I've tried to make abundantly clear is that I really celebrate competition because there's a very good chance that like, he would have uncovered, bugs in CTV by implementing tooling against it. That if he does something really well, I can learn from that. And if I do something really well, he can learn from it. And ultimately, like if I didn't have to write this code, I'd write other code. Like, so I'd be very happy if other tooling solved these problems better than I did. But I think Sapio is better, so I continue to work on it. And I think Sapio is maybe better for more generic covenants because you're using a programming language, Rust, that like is a real programming language as opposed to like and with no shade at all to Minsk, it's like a hobby language. So like if you're trying to do like some real computation of figuring out what your covenant is supposed to do, like maybe it's harder to do that in Minsk because it doesn't have like I don't know, all the libraries you might expect. So you definitely like different different use cases.
Can you just revisit the difference between verifying and proving authorization?
Yeah. So this is an example where like an outside of Sapio thing would be that an intent generator would be to I would like to sort this list, and a authorization prover would be I sorted the list, and a verifier would be I scanned over the list and checked that all the elements were in order. And those might seem like they're the same thing, but they're very different things in general. And for like a transaction in particular, your intent generator could be, I would like to only send to transactions which, I'm trying to think of a fun example, which have every other input be the prime factorization value of like the next one or something like that weird thing, right? And then the authorization verifier would be like, look at them in this order, right? Because there's a specific, like if you don't know the order, like, and this is a stupid example, but like if you don't know the order, it's probably not even correct. If you don't know the order, like you can't figure, it's an NP-hard problem. You can't figure it out, right? Something like that. And then the verifier just looks in that order. And so that's where it's kind of like 3 separate properties, and the automatically generated like thing, the verifier is what goes into Bitcoin consensus. The prover is what goes into your wallet, and the intent generator is like kind of also in your wallet, but it's like the literal transactions that actually get played is a part of those intents, if that makes sense. That's sort of you have to prove that that's what you actually want to yourself. Does that help at all, or is it still kind of vague? I can try again. Huh? If it's not clear for you, it's probably not clear for anyone. So I'll keep trying. Does anybody else have any, if it's like clear for anybody, does anybody else want to try restating it? Okay, so it's not clear for anyone, see? So let's see. Yeah, that's the plan. That's not clear to me that it would make this part more clear, because this is kind of like the theoretical underpinning, and you wouldn't get exposed to that just like using it necessarily. I think like an example of a covenant that you would have would be like so I think if we go back to our earlier slide where it's like mutable transaction graph, right? The intent is that every time this covenant plays forward, we keep sending a payment of equal value to these two people, right? And one thing you could imagine is that, let's say you wanted to change the addresses for the two people over time. At every step of the way, you would maybe have something that is a proof that like those addresses have like been signed by the person's key. And then imagine, sort of, and I'm going more complicated because I'm trying to, unlock, some bit of orthogonal, brain cells or something. But it's like, imagine that like the prover proves that these are signed in zero knowledge in some way. So it's like and the verifier is checking this thing, but it's an arbitrary property. That's not something that you can, like from the proof provided, it's not something that you know even what the thing is. And that's why it could be very abstract. Like, why is this intent allowed? Could be a zero knowledge proof of like, here's the actual program of all the intents. And so for things like CTV, the reason why this is really simple is because we have this finiteness property. So all of the set of our intents is always kind of like there's a small issue, bug in the theoretical treatment of this, but like ignore it for now. But like it's always just a literal list of transactions, and so our our proof into that is just the providing of that transaction, and then the checking of the hash is what the verifier is doing. But if you think about like in a taproot context, like what if you had many leaves? Can the verifier itself, just from the taproot tree, like top level script, can it generate the proofs? No, because it's like hidden, right? So the state that the verifier has to have is kind of like much more limited than what the prover has to have. And the prover might need to like ingest things like private keys, for example, in order to be able to produce these proofs. And you don't want to give those private keys to like just anybody, because then they might be able to generate proofs for intents that you didn't authorize. So that's kind of where there's like this like trade-off. And I think if you want to get like more like of a full understanding, you have to read the Calculus of Covenants post I did on the mailing list, because that has like the full like more formal treatment of what are these things actually. And like there's like a couple layers of like wrapping and abstracting that goes into that. But it's a more thorough, like less hand-wavy presentation. But it's probably like requires reading it a couple times. It's not like an easy concept.
So I'm going to see if I can try and explain at least part of it. So on slide 16, one thing that's helping me to understand, if I understand it correctly, so I might not, and this might be wrong, but is comparing, like as Brian was saying earlier, there's the like CTV things can be done with pre-signed transactions, but there's trade-offs. And so if we're thinking about in slide 16, the authorization, that this step of authorization, if you're doing it with a pre-signed transaction, for example, the send to mom, that's easy with CTV because we can just verify the transaction hash, and the data's right there, and you can kind of prove it in place. But a proof for doing this with the pre-signed transaction, I guess, would also include some proof of the destruction of the key, because if the key used to sign it is not destroyed, then you can't actually prove that follow-on transaction would be possible.
Yeah. So I think if I recall, like when I did the formal mailing list one, there's like, I think like 7 actual properties that are kind of associated ones, like assumptions. What are the assumptions? Is the assumption...
You compared it to multisig as well, I think, which I think was helpful.
Yeah.
Like multisig can be done, can be viewed, like a string of multisig can be viewed as kind of as a covenant, but there's like, it's a little bit more difficult to get the same guarantees.
Yeah, the way that I kind of think of that is that like whether multisig is or isn't a covenant, it is the category of thing that can be described within this framework, which also can describe covenants. So my sort of triangulation is that like, if we call this thing that I've described a covenant, then multisigs are a covenant, is sort of my, mental model, is that, maybe, and that's a little bit too prescriptive, because I've made a model that covers these things and then said anything under this model is considered this thing, but this could be some other thing. Maybe this is not covenants, maybe it's, advents. Yeah.
In that model, any script would be a covenant.
Possibly, yeah. I mean, I have been on the record saying that I think time locks are considered a covenant because it's an additional restriction on how the coins can be spent above and beyond, like, authorizers. I don't consider just authorizers without explicit instructions on what to do a covenant, although you could say that it is modeled as a covenant with no restriction on how it can be spent. It's sort of one of these things of like, we can describe these things in this language, and we can talk about like the cardinality of these things. And then when we want to talk about useful covenants, we talk about ones where we can like maybe bound the set of outcomes somehow. So it's kind of a like, I think that's sort of a thing that we know about formal models, is that like, one, there's always things that you can't prove in them that are things that you might want to prove. And then, thanks for Godel for that. But like also that generally you can prove like quite a lot in them. But it is a framework for like comparing, because I think what matters more is not whether you can describe something in a weird way as one of these things. It matters that like you can describe 2 things that you're trying to compare in this way, and then you have like 6 properties you can actually like toe to toe, look at them with. I don't know if that's helpful. Did you have a chance to see the post, the calculus of covenants one? Yeah. I've been told that I am writing too much and I should write less, so that's on me. I think just making it really concrete also helps, like what's going on and like what is the sapio, because like this is the calculus of covenants, like the sapio calculus of covenants. It's like a generic idea. It's that book in the sky I was talking about earlier. And like, what does this actually look like for sapio? It's like, well, get some Rust struct that has deserialize implemented on it so that you can like, and also probably serialize, but like maybe it doesn't need it. I think you just need deserialize kind of formally, but like read it from somewhere. You read the data in, and then you have some piece of logic for CTV enforcement or multi-sig enforcement of the set of intents, and then you add them to the contract, you bind it to WASM, and you use it, and then you party. And like that's kind of like, it's all you like really need to know to be able to do this thing. That's not like the full theoretical framework, but generally like Sapio is not trying to cover all possible covenants. It's just trying to cover like the ones that you're probably going to need to use to build something meaningful. There are probably other things that like maybe are a little bit out of scope, but like, do you really like, is this something that's solving a critical business infrastructure, problem? Like if it's not, like, I don't care to like, add the 10,000 lines of code to support that like niche use case, unless it's an important one.
I imagine we'll probably get to this in example, but could you define what add those to the contract means?
Yeah, we'll get there, I think. So here's a contract. This happens to be, I think, the same one that we looked at this morning, the James O'Byrne vault. So now let's look at, I'm gonna do some Rust. So you declare the contract. And when you declare a contract, you're declaring this, add it to the contract thing, like what are the bits of the functionality for this thing. So we have then, which is something that's enforced by CTV. We should be able to back up, and we should be able to begin redeeming. A vault also kind of has a notion of like a state, and we'll get into what states a vault can be in. But there's also an updatable thing, and the updatable is how we might spend directly out of the cold storage emergency path. And maybe I should rename it from cold to emergency. That might be a better name for this path, because cold and emergency are kind of different things. And then there's spend hot. And those are the two paths of like doing an updatable thing where we request the vault to create an output for us somewhere. So those are the things that are, sort of signature enforced. There's some key that can authorize this thing. This gets a little bit to like your question of like, well, who's enforcing the covenant? In this case, this is what we're enforcing out of our emergency spend path. And the idea is that really we could do whatever we want as soon as we access that, but what is it that we want to do? And what is it that we want to do out of our hot path? And the covenant is not forcing us to do those things, but it's helping us succeed at the goal that we have of not signing things outside the scope of what we have said we wanted, if that kind of makes sense. It's not making you do it, but it's helping you do the thing that you said you wanted to do. And then we say that the vault that we want to start with is the one that's in the secure state or like in the locked state. And then we register it to the WASM interface with this register James vault, and it's got this, handsome picture of James. Next, this is kind of like the deserialized part, is what's the actual data that our contract needs? What's the information that we have to have in order to be able to build an instance of this thing? And for the James vault, we need to know, one, kind of like what state it's in. We need to know a timeout for it. So that's some relative time lock, could be height, could be time, whatever your preference is. We need to have some hot key that we're using to sign as our hot wallet key. Not an address, it's a key, because we're going to sign using that. We need to have some backup key where, well, we don't need to have it, but this is a sort of a thing that came up in feedback to James's vault proposal was like, maybe it would be nice if you could directly spend from the vault before it's been attempted to be opened. It's sort of a precarious situation. What if you could just directly use the emergency key and you do it that way? So that's an option. If you provide a key for the backup, you could immediately use it. You don't have to. Then there's a backup address, which is if we decide that we need to send the funds in an emergency to our backup location, what's that address? That's not really a key because we want that to be like maybe an arbitrary multisig, maybe some other contract that we built. So we treat that in this example as an address. You could also have that be, for example, another smart contract. Maybe backup is like geographically sharded to like 10 different outputs that are each single signatures, but you're expecting that you're going to be able to get access to 60% of them. And that's a different security model than traditional multisig, because traditional multisig is all or nothing. This is, whichever ones you can get your hands on, you get a percentage of the coins per each one. You have a lot of choice in what would go there. But here it's just an address. Then you have a default fee rate. This is just to kind of help you along in terms of you need to say what the absent using a child pays for a parent, which is the next thing, how much fee should each of these nodes be paying? This is something that personally I have a proposal that gets rid, and for good reason, of fee rates in transactions and CPFP and RBF, because they're all garbage and they're all not good for clean conceptual models of how transactions should work. Because when you do a transaction, it should be the exact thing you want. It should not be how the thing is being paid for. I'll talk about that all day, but we can talk about that later. So it's a default fee rate. Bitcoin sucks. CPFP, same deal. If you want a CPFP output, which you probably do, you have to ask for one. And then this phantom data thing is like a Rustism, where if you have a type that is not really used to hold data, you just need to tell the compiler keep track of this type somehow, and it doesn't ever actually get compiled into anything. So this is now where the state comes in. So a vault can be in two different states. It can either be secure or it can be redeeming. We saw this earlier. In the redeeming state, after it's been redeeming for a certain amount of time, then it will transition into being spendable by the hot wallet. And so what we do is we use a little bit of kind of advanced Rust stuff to say that there's a trait for state, which is implemented by secure and redeeming, and there's a function is redeeming and a function is secure. And what do we want to have happen in our contract when we're in the state of is redeeming or is secure? Well, we're going to require something, and then we specialize it for each one to say that if we're in the state secure, then we're not redeeming, and if we're in the state redeeming, then we're not secure. So sort of annoying Rust. That's a little bit of boilerplate to do, but essentially what you end up getting is when we're in the state secure, we will have a function that we can call that says is redeeming never, and it says is secure required. And when we're in the state redeeming, it will say is secure never, and is redeeming never, is redeeming required. And so what that will do is that will allow us to conditionally turn on bits of our vault contract, which is kind of, it's a little bit advanced, but like kind of helps you think about like how these things are kind of handling, generic states that a contract could be in. We talked about dynamic state earlier. This is kind of dynamic state in a single type of contract. You could also unroll this into just different individual contracts at any, make the concrete things completely separate, but I did it this way. So now we implement the bits of functionality that we saw. So as a reminder, we have spend cold, spend hot, backup, and begin redeem. We're going to need to actually define what those bits of functionality are. And this is kind of like a little bit in the weeds, but like pay attention for at least like one of them. So we have the spend hot path. Now, spend hot should only be compiled. Compile spend hot. It's a compile if conditional compilation. If we're in the state of is redeeming. When we're in the state of is secure, none of this code will matter. Keep that in mind. When we're in the state of redeeming, this code is active. And you can see maybe why this is a nice way of thinking about these things, because you can concisely express like, a contract that can go into many different possible states. And then Sapio reaches those states as it unrolls. So now we have the hotkey, and the hotkey, as we said earlier, it is a clause key and a timeout. This is a policy manuscript fragment. I call it clause for convenience, because kind of some logical clause you want to enforce. And then we have a spend hot, which has this macro over it, which says this is guarded by the hotkey clause. This is only compiled if compile spend hot returns required and not never. Coerce args, you can ignore that. That's just a quirk of the type system to be able to serialize and deserialize the arguments into this. And then web API just says this is something that should be exposed with a JSON interface for this contract object. So you can kind of ignore those last two. They're just kind of things you have to do. And then what spend hot actually does, and this gets a little bit into the intent generation, is we pass into it an output that we want, and then it creates a transaction template doing this stuff down below with a label, spend via hot, a color of red, a sequence of the timeout that we have, and -1 just is, kind of reverse index is the last one. You could do 0 here as well, force a habit. And then add output, and now you add an output for the amount going to the hot address that you have specified in that output. So you see here we unpack the output into the address and the amount that we want to have. And then we say the purpose, just as some extra fun metadata, which is like the purpose of this is funds transferred out of the vault to this address. Does that make sense as like what's going on here? And do people see how that maps onto the concept of like you have some intent, which is like send to an output that I've requested. You have some verifier, which is only if it's signed by this key after this time. And then Sapio generates the UX that lets us actually make this thing, and that's the authorizer. Does that make sense? Is anybody super lost? Is anybody mildly lost? Mildly lost. Okay, well, look at another couple examples, and then you'll see a bit more. So now we have the cold path, and the cold path is one that should always be available. So whether we're redeeming or whether we're secure, we should always be able to back the funds up in an emergency, right? Does anybody think we shouldn't back them up in an emergency? Okay, no, we all agree. Back them up in the emergency condition. So here we say, let's see. All right, so this is the case where we have an additional backup emergency key we want to be immediately usable. So these are both filling in, mind you, the functionality up top, the updatable state, where you pass in some argument and then Sapio generates for you the state transition. So here what we do is pretty much the same exact thing. It's just with a different key. So it's like, look at the difference between these. What's the difference? Like, all I see is that the cold key is one that's optional. That's the difference. And I also see that there's no time lock on when we can use the cold key because we always want to be able to do that. Otherwise, spend cold and spend hot are like basically the same function other than metadata. Do people see that? Like it's the same except for the time lock? And what I want to highlight with the time lock is note the intent generator, which is this spend hot function, sets the sequence here. That's setting the intent of the type of transaction should be valid. And then we also have to enforce in the verifier the time lock as well, set timeout, right? You know, self timeout inside of here. So that's sort of one of these things where if you just put it in the intent generator, it would become only client side validated. It wouldn't be consensus validated. Okay, now moving on. Now we're looking at the things that are done with CTV. So we should, again, always be able to back up. And what this does is this creates a backup transaction with a CPFP optionally to be able to bump that fee, but sends all the money to our backup address. And then we have the begin redeem. And now begin redeem, we shouldn't be able to begin redeem once we're already redeeming, because that would be an infinite recursive covenant, right? You can always keep on begin redeeming. Maybe you want that, but we can't model that in Sapio, at least not yet. But not with CTV at least. But with begin redeem, we're only going to do it when we're secure. And what we're going to do, and this is kind of like the really, really magic part, is we are going to send the funds other than a CPFP hook that we requested. We're going to send them to a vault in the redeeming state. So this is a path that's only available in the case where we are secure, that we transition to redeeming. So you can imagine the state diagram of secure can go to redeeming, but redeeming doesn't go back to secure. Redeeming goes to like, it's been backed up to your emergency location. And other than that, it's kind of the same. Does that make sense to people? Just like a high level thing. I mean, I can try to, over here, if I can remember which one it was. Let's see, I think it was this one. I'm probably not going to be able to remember right now. I'll try like one or two more. I feel like I've got too many NFTs in this. Let's see. When did I feel like, so Vaults was the first one that I showed, but I was here early, so it's the first one after 9:30. So it's probably 10:14. Nope. Very suspicious. Oh, I'm in the default workspace. That might be why. I think I was in, there we go. So it's the one, maybe is it this one? Oh, that's a vault. There we go. So now we're looking at the thing that I was talking about with the vault, and we can see the time transitions here. I need to, yeah. So you can see this. I believe this one had a parameter of like 3 blocks or something like that. But you can see that whole flow where we have the initial state of the contract, and then we have the begin redeem path, the backup to cold path. And then after begin redeem, we're still allowed to back up to cold, but our spend via hot is blocked until enough time has passed, and then it's allowed to go forward. So that's sort of like the thing that Sapio outputs, and then this set of intents is what we view as our UX, and then we're able to do things in that intent set, like also like express that we would like a different intent, like I would like to spend hot, or I would like to spend cold, and then it will trigger those functions inside of the contract.
So it's basically like each of the methods that you're defining on this vault struct basically represent, or I guess if it's a then, so I don't know what these are called in Rust, but you have the like function begin redeem with a then guard, I guess. That represents a spend path in the visualization.
Yeah. So anywhere that you see, so like this begin redeem is a then path, right? And you can see where the metadata is coming from, right? And so begin redeem is made by a then. A then can return a list of transactions. Here it only returns one, and that's what gets made. And this is the new instance of the vault thing that is in the state of spend hot is available. So when we click here, you see how there's spend hot and spend cold because we're clicked on this one. If we clicked on this one, we would only have spend cold because spend hot is not enabled, but we always wanted to have spend cold available. Does that make sense a little bit?
Yeah, I think so.
Yeah?
Other questions?
Sure.
Could you show briefly, given the code that we were looking at for the vault, how would I manually draw this graph? Is it just by going to each type and looking at the properties of it, and I'm able to draw out that graph?
What do you mean manually draw it?
Well, like on paper, by hand. If I was looking at the code, I should be able to translate that into the graph that you were showing, right?
Yeah, so I mean, I guess like where I'm not sure of like the like well-formed question of that, because I would just say you would draw it like this. So I'm not sure like what's the gap between like what you would hand draw versus this.
Well, in particular, so you start at one of the types, and like I see outputs here listed, like output 1, output 2. So somewhere in the code there should be an output 1 and output 2.
Gotcha. So what you're looking for is like arrows from things here into the code. I can't draw that for you right now, but if we just go back and forth on like, let's focus on just this begin redeem. Begin redeem is a transaction, right? And it's got something for 10,000 sats, probably CPFP, and it's got 0.999858 Bitcoin. So let's now look over here. We're at begin redeem, right? And this is only in the is secure state. Let's verify this is in the is secure state. Looks like it, because here we only have spend cold. So this is coming from, only enabled this path. We don't have it recursively, right? So that's why it's only appears once. And then now we've got two outputs. Where do those come from? Well, we have a template. So let mute template equals context.template. Now set label, begin redeem. That's where begin redeem is coming from. This color is not like super pink, but like I promise it is like a faded pink color. But here we've got set color pink. And then we have, first we add as the 0th output to this template, we add a CPFP hook, purpose CPFP anchor output. That is this one down here. And I think I broke this recently to make another thing work, but in this key value thing, it would show you, before the patches I made last night, it would show you like purpose, CPFP hook. And then the address corresponds, because if I click on this, you can see the address that corresponds to the one that I put into the CPFP hook thing. And then here you have this begin redeem, and that's a vault that's in the state of redeeming. And then that's what you see in this entire subtree here, is this is a vault in the state of redeeming, which has both the spend cold and the spend hot. And then the sub transactions are two. This one is a then. There's only one then in the state, which is back up to cold. And then this one here was generated by a call to spend hot. Does that kind of map out clearly like where those things are coming from and how the code translates into that graph? Cool. Fantastic. Yeah.
I think it'd be helpful to walk through the top level macros again and just kind of explain maybe what each one does.
Yeah. So, I guess it's not in this presentation. I thought I had this in one of the presentations, but perhaps not. So my oversight. let's go to learn.sapiolang.org. And we'll go to, I'm not going to say the documentation's really good for Sapio, but it ain't bad. So like for a lot of these things, like you should just like check out, the written stuff. It's a little bit hard to keep it all in sync because I'm still improving things a lot, but we can click contract actions and there's a little table. Guard, create a clause using Manuscript with access to the contract's values and context. Compile if, determine if a then or finish should be compiled based on the contract's value and context. Then, create a path or paths that are guaranteed using CTV or a contract to be spent with optional guards and compile ifs. Continuation, create suggested path or paths for a contract to be spent that are not guaranteed via CTV with mandatory guards and compile ifs. Also accepts an update argument for generating transactions based on future data. You can ignore the decal one. And then guard, so we can see down here, guards are central to any Sapio contract. They allow declaring a piece of Manuscript logic. That's basically what they're for. There's a couple like interesting things, that you probably don't need that I probably should remove because they're too interesting and like I've never used them. So, I thought this was going to be like a big deal, but I didn't use it. So this caching thing, kind of ignore. Then conditionally compile if. Honestly, this one is really, really useful, but incredibly confusing. So there's like this whole like set of like inference rules for this thing of like, there's this whole conditional compilation thing of like you can mark branches of code as being skippable, nullable, required, never, no constraint, or fail. And then there's a set of inference rules for like which takes priority over which other one. Pretty nuanced. Most of the time you just need like required or never, but there's certain cases where like writing really, really generic modules, you'd want to have like this full thing of like, oh, like this one rule has said this thing shouldn't be there. And the nice thing is that you shouldn't use this really to like enable functionality, but you should use it to basically generate failures that like, hey, our contract has somehow asked for an illogical state where something is both required and never. So we should now fail is kind of the purpose of some of this stuff. But this can be used, if you have like imagine you had a contract that instead of having one state of redeeming or secure, imagine that it's a multi-sig covenant. So it's fully recursive, under the multi-sig. And then there's like 20 different state variables. And you've got this thing where you're like, yeah, this is awesome, kick ass. Like we're going to have this loan and the loan's going to have like 30 different states that it can be in. This would help you like turn on and off logic and then fail if you've reached an inconsistent state before you transition into it. So kind of useful in that regard. The then is sort of, because the ones that we reviewed, the guards and the compile if, like those all go into the next two. This is just like a CTV related thing. So whatever transactions get returned from this branch of code, those are enforced to be locked in by CTV. And whatever guards are there are sort of additional as well. And then continuation, and like behind the scenes, it's not quite done this way entirely in the code base, but like then and continuation are the same thing. It's just a convenience that like, there's no argument when it's a CTV. But a continuation is a relaxation of no argument and says you can pass some additional data in that you would find out about later. And that is sort of like the argument that you're passing into the covenant to like determine what should happen. So for example, if you had tap leaf update verify, this would be which party is trying to withdraw and how much are they withdrawing from the payment pool in TLove would be the type of thing that you would pass in here. When I work on like DAOs in Bitcoin, like this is like, what payments should the DAO be making? What's the balance sheet that we're processing? Things like that would be passed in here. And then you generate from that whatever state transition you think is appropriate based on the information coming in. So those are the different guards that come in and the different things that you can define. And then after you do that, you do this contract declaration where you actually bind it to the contract. And there's a lot of like weird stuff to support some of this conditional compilation stuff that you don't really have to fully grok, but it's rad when you need it. So you'll see if you look at like the examples in the code base, like you can see some places where these things are pretty nifty. And they're good for like when people are writing and reviewing contracts, it's nice to like have like a single contract body that you can kind of, read the minimal amount of code and like understand what states it's in. But if you don't like that, you can always, get rid of some of the generic stuff. Let's go back over here. Does anybody does that answer your question sort of like what are these things and how does that map to like what each of these are? Yeah, I mean, ultimately, like, if you want to understand this, you're going to have to read through the compiler at some point. It's not like, C++ where you can go to, and CPPRef and like, language lawyer your way out of it. Like, at a certain point, if you want to understand what's happening, like, it's still at the phase of where you need to read what's happening in the compiler. Like, last night I was working on something that's like kind of an edge case, but like an important edge case, and I realized that like I made a bug, and I was like a while ago, and like if it's still alpha software, but it's getting there. That bug isn't there anymore, for example. So yeah, like Manuscript, yeah. So yeah, actually, it's interesting. I've actually found a lot of bugs in like Rust Manuscript because I'm like this big user of it, and I use it in like very like hefty ways, and I'm like, this doesn't work, that doesn't work. Here's a edge case, and I think generally like testing in the Bitcoin ecosystem is like pretty harsh. So like harsh isn't like hard to do. But yeah, at some point, like as like a follow up to this, like doing a workshop where people actually read through the compiler would probably be fun. But it's just like the introductory workshop, like that's probably like too much, but fun nonetheless. Any other questions? All right. The last slide that I have here is just sort of like for like inspiration, and maybe this is a little bit, like more what's being asked is like, it's like, well, like we saw like a really concrete version of a vault that like makes like one instantiation of that happen. But I mentioned like maybe instead of an address, you could have like a module for hot storage and a module for cold storage. And then this is just kind of the thing I want people to have in mind is like, well, like what happens when we have Sapio modules for a cold storage contract and Sapio modules for a vault contract and Sapio modules for a hot storage contract. You can kind of compose these things, and you could have really like, if you had to like, have like devs working on different parts of your stack, you really might have like devs who are only working on your hot storage wallet, only working on your cold storage, and only working on your vault backbone. And then those things can compose together. So that's kind of a cool property. It also just helps like if you have like common tooling and like, let's say a hot storage module contract can be emitted out of some other thing, like, well, then you might have a whole service for just managing funds that are under your hot storage module. And then you might have other tools that like hook into that. And so it's kind of nice for code reuse and like composability. And I think composability is this very important thing that has previously, not been super appreciated in Bitcoin contract writing, because it's just, do a one-off thing for this, do a one-off thing for that. But when you can write an interface for something and then, you can write multiple things that satisfy that interface, then you get a lot of, experimentation can happen and you can make a lot of cool things. So we can stop for like a couple questions. I might grab a water. But then when we're back from that, how much time do we have? When are we going till? Like 4:30. Okay. Yep. So we'll then do basically a primer on just like what actually is CTV, like hardcore, like, what's going on there. And then Manuscript, we'll do a quick,
I think the CTV one, that's probably why I need permission for that, which means other people do as well.
Oh. Okay, should be anybody you can see. And then we'll do some Manuscript stuff, and then a little bit of Rust, and then, or maybe we'll skip the Rust one just because, I don't know, like let's get the software running, and then we can do that one later if there's time. Just checking in, seeing everyone's doing okay. All right, so I'm big on repetition. So CTV is a verifier, satisfier, intent triplet, right? This is a framework we've been building on. Intent is only this transaction. Verifier, this transaction has this hash. Satisfier, the transaction. couldn't be much simpler. Is it stupid? I don't know. Yes, right? CTV is not designed to be this like, galaxy brain, like, incredible opcode that like lets you, it's like, no, it's the stupidest thing you could come up with. And that's that design specificity. Like if I told you what CTV was trying to do with that spec of the intent, satisfier, verifier, you would come up with pretty much the same thing. There'd be like almost no other way of doing it. And normal triplets, you'd be like, well, we want many possibilities. Nah, CTV is just the one. Complex satisfiers, nope, just the transaction. Complex verifiers, nope, it's just the transaction. So all these things are like, I think that this is why people maybe hate on it, because they're like, this is so stupid. We can obviously be smarter than this. It's like, well, sometimes stupid is the smartest thing. So, what's the cost of these smarter things? Like, I don't know, like a lot of complexity. This is basically all you need to know about CTV. This is the definition in a denial of serviceable way of the hash function that CTV computes. And we said earlier, CTV is just the hash of this transaction matches. So what are we actually computing? Well, we're hashing the end version, the lock time, all of the script sigs, if there are any present, the length of the number of inputs, the concatenation hash of all the sequences, the concatenation of, or the length of the number of outputs, and then the serialization hash of all the outputs, and then the index of the input currently executing. And we build that up into a byte buffer and we hash it. That's it. Like there's nothing else going on. Technically, there's like two different versions of the hash that get computed if there's script sigs or not. There's no like super nuanced reason behind that. It's like maybe one day in the future, nobody's using any script sigs anymore, and you're trying to do this in like some sort of opcat covenanty thing, and it's just one more fucking thing you got to jam into your script. So like we let you not do that, but there's no ambiguity. It's like one message has one length, the other has another length. There's no possibility of overlap or misinterpretation. If the transaction with all these things hashed matches, it can go through. If it can't, it cannot. Like, that's it. That's CTV. If it's on this, we should do those t-shirts. You know how people are like, oh, we put the formula, like we should put the hash on the t-shirt. Like this is all the really critical code for CTV. Nothing else really matters. There's like, obviously, some stuff matters, and this is Python, but like, if you understand this, you understand CTV. Does anybody have any questions? Yeah.
Why is it important to include the version of the transaction?
So one of the properties that CTV tries to ensure is that if you have a chain of things that are insured by CTV under your model of malleability, so for example, like n of n, but you're one of the people, so it's not malleable from your perspective, you could have at the terminal leaf of that something that you could pre-sign without using something like any prev out a transaction from, and rely on the stability of that pre-signed transaction. That enables things like non-interactive composability, where you can do things like create lightning channels that are coming out of vaults, for example. If you don't commit to the end version, then end version would be malleable, and somebody could recreate your transaction with version 3, version 4, version 5, and then you'd be screwed. So that's why we commit to it. Should I pop quiz people? Why is the n in committed? We can go through every field. The BIP also has a justification for everything and every order that the fields are in as well, which is also kind of doesn't really matter, but maybe there's some later significance, and I tried to do a like not bad job of guessing what that order might be. That's why version is first. I don't think you're ever going to change it dynamically in a covenant, but it's got to be committed. So, any guesses on NN of why we've got to commit that? That's the input that is currently executing's index.
I think you have to do that. Otherwise, you have the half spend problem where you could have two identical CTV encumbrances and come up with a single set of outputs that satisfies both encumbrances, and so basically half of the coins you're spending disappear.
Yep, that's absolutely it. There's more details on that in a bit, but I've got a follow-up question for you. If I wanted to do that and I wanted to opt into that, what would I do?
I guess you could specify one index to be 0 and one index to be 1
Sure.
when you're
Yeah.
committing.
And with Taproot, I could even specify each input has one version with 0 and one with 1, and they could go in either order. Yeah. Right. So you have a lot of flexibility with that. If you do more than one input in general with CTV, you lose a lot of this ability to prevent malleability because any input could satisfy that. The original incantation of CTV did not allow more than one input. Russell O'Connor asked for me to allow more than one input. And so then the half spend problem was created, it was solved, but there's no fix for the malleability problem at large. There's some interesting things you can do though, but that's why that's there. So good job. Does anybody know why the length of the VIN and the length of the VOUT are separately committed when they're transitively committed already? Transitively committed meaning the length field in the hash of the end sequences commits, to the number of end sequences, which is the number of inputs, and the serialization of the output data is unambiguous, which means it also transitively commits to the number of outputs. But why commit to it separately? Any ideas?
Is it for like future scenarios where if you're like calculating this dynamically with like opcat or something like that?
Yeah, exactly. So you might want to have a covenant where you say you may add any one output that you like. So how would you do that without the length thing? Probably pretty tricky. With the length thing, you just say, this is the exact length I'm expecting. One of them can be added later. If you add not just opcat, but op-shawstream, that's even easier to do because it's a kind of semi-Merkleized representation. Let's see. Here's a tricky question. What happens if I want to have a lock time with my CTV transaction, with my CTV opcode? I want to also have a lock time. How do I do that? Do I use check lock time verify? Do 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 do.
You just commit to the lock time that you want in here, right?
Yep. What would happen if I committed to in the lock time height? I don't know, 2 million, and then in the script I also had a lock time of 2,000,001.
Would it be burned?
Yeah, and then what if I had in the script a lock time with time 0?
Then you're okay.
I think you're also burned because you can't have both a height and time.
Yeah.
So maybe 0 is okay. That might be a trick value, but like time 1 or something would also be burned. All right. So is anybody like not sure what's going on with this hash function at this point? How about the script sigs? What's weird about committing to the script sigs?
So what's weird about that is that for pre-SegWit transactions, you're going to have content in there. It's not just going to be a degenerate blank value. So you're actually committing to script content in the inputs. But post-SegWit or Taproot, there's no content that you're committing to there.
Yeah, that's absolutely correct. And so if you commit to not having any script seg hash here, you're saying none of these inputs can really, well, they can be, but like an opt true or something like that. But none of them can really be legacy, with something meaningful. But what happens if I commit to, for example, one other input, and then I commit to a script sig that has an ECDSA signature in it? Is that valid? Or like, could it be valid? Yeah, and if it's a real signature, what does that signature commit to? If it's an ECDSA signature?
It commits to the encumbrance of the coin you're spending.
Yeah, so it would not commit necessarily that coin to be spent with your covenant, but it could, but I think there's a hash cycle issue there. But if you use like sig hash single and sig hash anyone can pay or something like, or I think just anyone can pay with that one, then you are able to commit that path could only be spent with that specific coin, which is kind of weird. Now, what about P2SH? And SegWit P2SH. Is there anything weird about that? Because now for P2SH, it's basically the same as legacy script. But what about, it's a little bit different. We commit to the entire program. But what about P2SH SegWit? Is there something weird that happens with that?
No idea.
In that condition, we're committing to the script pub key that we have to be co-spent with, but none of the signature data. So we're able to say that under this, we require some coin that had this key, but we don't say which one. So that's an interesting one sometimes. Some of these things you can combine in some non-obvious ways. For example, if you somehow pre-sign with ECDSA and you sign that there's a specific relative time lock, then you're somehow able to restrict, certain things. For the most part, all of these things are like not really malicious. They're just sort of like rough and interesting edges of like what you might be able to express. They're all things that you could also express with like normal signatures usually. So they're just kind of interesting trivia, points that probably nobody builds anything with. But I think they're all tested in like the Python tests. So that's a lot of grilling on CTV. So thanks for putting up with that. Basically, all you need to know at the end of the day is it's just a signature with no elliptic curve. It's just a hash. You can yeah. So I think we'll skip this because we've done a lot of like this specific example, but I would encourage everybody who's like, there's a lot of stuff going on to just like look at James' code because it's just like very, very, very small for what it does. It's really not hard to do any of this stuff. This is like 1,000 lines of code and it's like a complete application. Yeah. So yeah, it's I think it's only mildly more lines of code than the consensus code changes for CTV itself. So and it's like none of this stuff is like that hard, to do. And I think that this is one of these things where like it's something that maybe I say often is that like CTV has already had significantly more review than Taproot, and that's just not a statement of like the total amount of review. It's a statement of like, it's just really, 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 really small. So even if like the smartest developers only spent like 1 hour on it, the amount of surface area we're talking about is like it's just very tiny. So it's not like that's an excuse that it should have like some lower bar of review, but it's just like we have to be clear with like what we're talking about, which is like something that is really, really straightforward. So that's it for what CTV is. Does anybody have any like burning questions or like still doesn't get it? It's fine to not get it. Like, it's my failure, not yours. I'm not running out of power. My laptop is. Just kidding. Thank you. Well, theoretically, you can daisy chain them. Oh, I think actually if I. Oh, cool. Yeah. All right, that works. Thank you. Yeah, sure.
Do you see CTV composing with things like cat and check sig from stack to accomplish some of the more lofty covenants goals that people talk about?
Yeah, absolutely. So if you have check sig from stack, that is probably like the right thing to incentivize. And maybe, I know you guys are thinking about like a bounty program for things, but like I've been talking to some people about doing a bounty for check sig from stack. Super straightforward. By itself doesn't really introduce anything like too, insidious, but check sig from stack and CTV actually let you do something similar to any prev out. So this is again kind of this thing I was complaining earlier about. It like people are like, oh, like CTV is not the simplest thing because you can do something like CTV with APO, but it's vice versa. Like CTV plus check sig from stack gives you something similar to APO. So I kind of think that those are kind of the two more fundamental operations. And that is related to Russell O'Connor's TX hash stuff, where it's like CTV is one of the possibilities that you can do with TX hash, just not all of them. And if you want to go down that, I don't know why that's going. If you want to go down that route, then what you would do is you would like have TX hash replace APO as well, because you would have one thing for doing signatures outside of the signature hash flags, basically, with a new signature hash language, basically. And so that's sort of where that is a strong yes example, and that enables, as far as I'm aware, with CTV, mostly like APO-like functionality, as well as other cool things like key delegation. Which is cool. Like you could have your emergency keys be used to authorize new online keys. You can't revoke them, but you don't have to, like if you want to use your emergency keys in an offline fashion, you can let your emergency keys authorize a new online key without having to have your emergency keys sign transactions specifically. Like kind of cool, custody related use cases for that. But for cat lets the cat out of the bag. Like that's like, it enables quantum proof signatures. Like it enables covenants, like recursive covenants. It's just like anytime you can think of something, like cat probably like does it. So people are like a little bit afraid of cat because we shouldn't be this surprised by the things that it can do. And until we like probably go for like a couple years without being like horrendously surprised by some new thing that we didn't think was possible, like probably people aren't going to feel super comfortable doing cat unless we like just go full Monty and are like, we're adding everything that we can think of. And that's kind of this, like, I don't know what the right call is there, but.
So when people say cat, is that shorthand for cat plus some kind of opcode that will push arbitrary parts of the transaction onto the stack? Because just having the concatenation thing doesn't seem sufficient.
Andrew Polstra has a good blog post called Cat plus Schnorr Tricks, where I believe just with cat and Schnorr you get fully recursive covenants. So, because you can basically use the ability to manipulate the sig hash flags in a Schnorr signature to leverage that into getting the transaction literal onto the stack, and then you can use cat to destructure the transaction.
That's horrifying.
Yeah. So I mean, like, on the other hand, there's a perspective that like, well, like probably like maybe we have something like this anyways. And I don't know if that's like true. Like I think some people are like, we can't analyze script fully to figure out these things. I'm pretty sure like script doesn't have covenants like this right now. But yeah, I mean, I think it's just like you can do way too much stuff with cat. So nobody feels like super comfortable thinking that like, if we ever want to say that certain features should not be available as opcodes, then we shouldn't do cat. I think if we cross that Rubicon, we say, well, anything somebody wants as an opcode should be fine, then cat's probably okay.
Right. Do you see CTV as kind of a useful way station on the way to the next kind of governance framework, or do you expect that it will be composable and will actually be practical as sort of a building block for the next thing?
So I think I have two responses for you on that, and then maybe we'll move on just so that we can.
Don't let me hold this up.
Yeah. So I think the first part of that is that CTV stands on its own. If you build something useful for you today on CTV, you will probably endeavor to use it for like decades or something. Like, it's not designed to solve necessarily like super sexy problems. It's designed to solve problems. And the types of problems it solves are things like, I would like a vault that is secure and I can build a security perimeter around better than what I'm doing today. And then when a new fancy sexy thing comes out and you're like, oh, the engineering complexity to implement that is a lot higher, it's not clear to me that you're going to actually do that unless there's like a very material benefit to it, which I think some people have complained about, that like maybe CTV disincentivizes our ability to get these fancier things. From my point of view, it means that like, no, that you just think that CTV is good enough for what people need it for. And then there's also other things like non-interactive, like lightning channel opens, which I think like that type of thing will just be like also useful for a long time. And like, probably there's not like too many ways of doing that, but maybe we come up with something better. But if it's working, like that's one thing that I think is sort of like the window is closing a little bit for like something like APO. Just a lot of the lightning people that I've spoken to are kind of like, we really like the idea of L2, but we have a shitload of deployed infrastructure that works, and switching over the entire channel protocol means throwing out most of that. So I think I've seen a lot of reticence to do that, given that like a lot of the issues are also like, it's not clear like if they're game theoretically desirable to have justice-less things. And also it's not clear that like the chief benefits, which are in my view around the ability to have multi-party channels, like it's not clear how important that is for Lightning topology to work well. So there are like certain things where like, at least to me, I kind of suspect that it would be around for a while in terms of being a way station. I would also expect that like if people are able to use this successfully and safely, it will be very good for making the case that like maybe other covenants can be good too. But if people really like struggle with it, it's pretty simple. And maybe it means more generally like the Bitcoin VM that we have is like not the thing that we need if people really endeavor to be doing more sophisticated transactions. And maybe I think if I were to have a critique of like how simplicity works and ties into this, which is sort of like the next thing, is that probably the space to be innovating is not in the script unlocking condition space. It's in the Bitcoin transaction space and in coming up with a better transaction semantic that would be more robust. And there's a lot of research going into that through the other communities of like non-UTXO based stuff. Even though we hold UTXO as kind of sacred, like ultimately we don't hold UTXO sacred. We have properties that we like for having a reliable consensus system. And if somebody else innovates on how we can offer those things, then like I would rather have that technology than the one that we have, as long as it actually meets the bill of reliability that we're looking for. And I just have a suspicion that simplicity with like the shitty Bitcoin transaction semantics is like not the dream team that people think it might be. But certainly there are people who are like proving me wrong on that. Like Barak is doing a really great job with Bitmatrix in terms of like showing like just how far you can push the UTXO set model. So I'm excited for that kind of stuff, but I'm just not like, I wouldn't give you like a high confidence interval in any of those things. Is that a full answer for you? All right. How's everyone else doing? Cool. All right, so this one's more fun. This is, who here knows Manuscript already? Some people. All right. So we'll do a quick one, and then this one's really playtime. So we'll do some playtime. Okay, so not so mini script. So raw Bitcoin script is, yeah, let's not do that. And then like, how about just the well-formed subset Peter, Sanket, and Andy said is good to use? Let's do that. If only life were so simple. Slide was originally not in this presentation when I did it for PlebFi. But since then, we've got like a new bug, and then there's been bugs before. And these are all terrifying and worrying, and I haven't yet even patched Sapio. So, that's probably going to be done, sometime in the coming week or so. Overall, this just means that like our ability to reason about these very complicated systems is like, it's pretty limited. So we're doing a good job though of trying to tackle the problem. And I think you'd still be more likely to have made a bug in your handwritten scripts than in Miniscript. But it does mean that this stuff is still early days, and you need to be careful and, audit your code and, I don't know, like audit your devs and stuff. So make sure that, you're not just taking things on like some narrative, that you're actually looking at, how well do you understand the properties of Miniscript, for example. And this was found by a user error. So like a user just had some weird thing happening. This wasn't found by like somebody understanding the problem initially and going like, oh, we have a bug. It was like in the wild, this thing came up. When we say well-formed for like scripts, what do we mean? Well, this kind of relates back to this intent stuff we talked about. Like we know how to solve for it. So if we don't know how to solve the script so that we can produce an authorization against it, we don't really understand what the script is doing. We can make sure that there's no like weird conflicts like older time and older height that we talked about a little bit earlier. Maybe it's not malleable. Like if we provide a solution, nobody can like tweak our solution and provide a different solution unless they themselves are a part of that script somehow. It's round trippable, meaning that like we can have our high level representation in Miniscript, turn it into a script, and we can have a script and we can turn it into Miniscript, and we can do that back and forth a billion times, and we're not going to have any changes. And we don't hit any of the weird limits like ops counts and things like that. So that's kind of the set of like things that are like well formed. There's probably some other properties too, but just to give you some intuition of like we do mean something when we say well formed. It's not just ones that we like.
That last one means just it would protect you from hitting those.
Yeah, like there's a bunch of weird limits like of what is considered a policy valid or consensus valid script. And you're very liable to hit them and not realize it if you have hand-rolled tooling. In theory, Miniscript can analyze that you're not going to hit any of those things in any of the conditions you expect to spend from.
And those limits change as well in different, like if it's SegWit versus
so
then it all helps for that too.
Yeah, I think it's sort of it's an argument in favor of hard forks. I'm just kidding. There's just like so much technical debt that we have for a lot of these like really weird policies that graduate to consensus rules over time, and like it's not really clear. Like, and that's why this minimal if thing came up, was like that was kind of one of these issues. It was something that they were checking, was valid against policy but not against consensus, and it's sort of I think there might be some truth in the people who think that we should just get rid of policy altogether and just say only actual consensus matters. And if you do something that's been marked socially for upgrade, you're going to get fucked. There's no protection against that because our ability to like really work with these like policy limits is like kind of limited. But policy limits also help the Bitcoin node not get denial of service attacked, which is it's a rock and a hard place. So.
Isn't there also recently wasn't quite a bug, but a wallet incorrectly formed some Taproot spend?
Binance, I believe.
What's that?
Binance, I think.
Maybe, because, I don't remember what it was, but then we basically patched it by enforcing something at the policy level, like, well, nodes just won't relay this.
I have no idea.
I forget what that was.
Probably. Anybody else know?
Ben, do you remember we talked about it at BitDevs?
Oh, well, that's this minimal if one, the minimal if bug.
It was like a Taproot key, but the alpha wasn't XL
Oh yeah.
But they didn't patch it actually because like Peter Wohl brought up like if I like posted this say to like a Coinbase batch thing, I could like denial service all of Coinbase withdrawals now if it wasn't part of policy. So they just like left the bug in kind of.
We will see another one of those shortly, where it's a bug in Manuscript, and I've tried getting it patched, but nobody else believes it's a bug. So
Scary.
I mean, yeah, you can be loud about it if you want to. Like, I think it should be patched, but nobody else cares. Okay, so one of the issues with Manuscript is it's actually like significantly harder to write than script. If you try to write like bare Manuscript, kind of like Rust. Rust is kind of hard to write because it protects you from doing things that are unsafe. So regular script might feel easy to write until it bites you in the ass and you fuck something up. And Manuscript like hopefully stops you from doing that. And that's why it's harder, because you have to actually like think about what you're doing and you avoid all these common pitfalls. But luckily, there's something called policy, which is a higher level language that compiles to Manuscript, and then Manuscript compiles to Bitcoin script, and then Manuscript goes back in that round tripping, and then you get a semantic policy. So you actually can't fully round trip this thing, but you can do something, and it's a lot easier to write. But it's not what you see is what you get. There's implementation details, and you can get different things. But Manuscript is like not really like writable by like mere mortal humans. Like I understand it about as well as anybody who's not one of the authors, and like I can't write it by hand, so I don't like I'm sure there's people here who could write it by hand, but I'm not one of them, and I wouldn't expect anyone to in the software that I write. So I use policy in Sapio. There's many implementations of it. One, it just recently got merged to core. It got merged with that bug that I mentioned. So like I was a little bit unhappy because I thought it's like too complicated to be in core. Like it should be like a plugin. But I wouldn't recommend using personally like the other implementations because I think that they have like less community around them. So I do recommend the Rust one, but that's not really based on like any like solid thing. I've not reviewed the C++ one, and I think like the Rust implementation like seems pretty good to me. So I would use that one if you can. And then I'm maybe not doing the best job of this, but we're gonna play. So playing will be easy. So Manuscript is also kind of like abstract. So like generally when you're writing a script, you've got to like fill things in like keys and like hashes and stuff. And Manuscript lets you write things like Alice and Bob instead. But this isn't really implemented completely the correct way. So you can only kind of use it. You can't like fully use it in the ways that you might want to. But you still can do something, and we'll see that later. So what can you do? That's like really the critical question. And this is what policy exposes to you. Everything else doesn't really matter. You can ignore the first two. That's just like something that you can't satisfy, something that is trivially satisfiable. But you can do a key spend. You can do an after, an older. Honestly, the names of those two things are stupid. I can never remember the difference. So like you have to read the comment every time until maybe it sticks. For me, it's never stuck. I always have to read the comment. You can do a hash preimage with a bunch of different hashes. And then you can do the and, the or a threshold, where it's like any number of these, like 3 out of 5 of these things of any of the above. So using this, you can build a lot of like pretty sophisticated stuff. You can also do check template verify, but I'm not showing it to you here because usually your tooling will take care of that automatically. So it's not one that you would ever, normally put in yourself. And then, so anything that you can write that you can express as like a combination of those types of things. So for example, like most of the Lightning protocol, I believe is expressible as like a combination of these statements of like an HTLC would be like, this key and this hash, this time lock, that kind of stuff. So you can express like a lot of different things. This is kind of an important thing is that like, you really could win a hackathon just by writing a really complicated Manuscript fragment that did a lot of cool things. Like I had this in the plebby thing because I was trying to encourage people like, look, if you're like way intimidated by this, just spend a freaking day thinking about end to end what a user would want an experience to be and like write the Manuscript that like does that entire thing. And that is actually still like a pretty big novel contribution because the reality is like people don't write that many complicated scripts. And a lot of the probably like 90% of the value of like some sort of application could just be like you came up with a novel set of scenarios and the corresponding keys with who might do that thing. And then you have like a new application that nobody's done before. It's not going to be something like wild and crazy, like, oh, it's a new state chains, like whatever thing, but like you can probably do something that's like a pretty cool custody protocol or something like that. And you don't have to write like any, real code. You just need to express what you want. Okay, who's ready to play? Anyone? All right. So you got options. I like mine because it's basically I just ripped out the Sapio Studio and put it into a web page, and then you click Manuscript Testing, and then you have something that's usable right away. So you can go and do that, and I'll show you how this works. I can't hold the mic and type at the same time, but I will set it down for a second and type some stuff, and you can kind of see what happens. All right. So the way that this works is every line is like an independent fragment. This is Taproot compatible. So I'm just going to start by typing pka, and it live compiles, which is a feature that a lot of the Manuscript compilers don't have. So this one's kind of convenient, and it shows you what the output is. So if I do something like this, and pka pkb, by the way, no white space is allowed, then it automatically shows me what the Manuscript fragment is that corresponds to that. If I do a new line, then I can do something like pka again, and then I get a different fragment, and I could do something like and this is just the things that you saw before of like all those things in the slide of like what your options are. This is policy that's being read here. So now I've got like the condition of like either Alice and Bob sign, or because it's Taproot, these are kind of all a top level OR together, or older, 100 blocks, I think, then just Alice's signature is enough. You could write this other ways, but this is like Taproot, so we only want to express the minimal condition. So we're not trying to write like some really, really big complicated thing with a bunch of ORs. Like we're trying to write the small Taproot versions. Does anybody have anything else they want to see on this? All right, cool. So then what we'll do is I need to copy some keys. 1 second. So that's a little bit of like niche technical stuff, but there's two different V's. There's AND-V and V decorator PKA. That basically means the form in which the thing coming out of this thing is verified. I don't know if that's like a useful statement for you, but like Manuscript generates these like weird, decorators and stuff, and that's why normal humans can't really write it by hand. I don't know, the composition rules. Like they're all on SIPA's website, but it's not something I can like load into memory for me. So, your mileage may vary. If you're smarter than me, like go for it. That's not meant to be like a rude statement. Like it's just like this is not the kind of information my brain handles well. So. So what I'm going to do now is I'm going to go to my Bitcoin D, and I'm going to get address info of, I'm going to get, don't ever do this, but I'm doing it, which is copying keys out of the address from Bitcoin Core, just because I need something that happens to be a key. But I've been told that bad things will happen to you if you do that. So now I'm going to translate these keys. I'm going to need one more key. And all right. So now you can see down here that it generates addresses for mainnet, signet, regtest, and testnet. And you can see the different branches. So there's one that's the public key 79, check sig verify, 64, check sequence verify. And the 64 is in hex, I guess. So that corresponds to the 100. And then down here, you've got the same thing, 79, check sig verify, 29, check sig. So that is also the thing. You have the paths that are the Merkle branches for both of these things, and then whatever else you want. Where this kind of is the limit. It doesn't really give you like descriptors or things like that. You could patch that in if you really needed it. But this is just kind of a playground of like, if you want to play around with Manuscript, like it's a convenient way for you to like test out like, oh, what would this look like? And you can do that. Where I'll show you a bug, which I promised I would, is if you do this, you're supposed to not use duplicate keys inside of Manuscript because it creates malleability, and Manuscript's supposed to prevent you from doing malleability. But now I've got this thing that's 7911 AC check sig verify 7911 AC check sig. So now if I provide two signatures to that, somebody can like switch the order of these things, and then that's bad. So that should not be done. And the reason for this is that the devs feel like you get what you ask for, and you ask for it to be translated this way. I'm a little bit more generous of like, maybe your tooling generated a key that was duplicate and like that was not intentional. Or maybe you like thought like, oh, what if Alice and Bob are the same person in this protocol? Then you put the same key in, and then you have something that's now subtly broken. So not the best case, but.
Isn't that kind of similar to maybe that's what the older after bug was, where if you have a transaction with, or is it the branches in one locking script, or is it?
Let's check it out. See, we're in playtime, so let's do it.
Let's play with it. Because Paul showed a good post on it, just explaining the challenges, and so basically, the idea is if you have condition that's either with like relative time or blocks, like it can only be one or the other, and you can't have both in a transaction because it's basically based off of if it's below a certain number, it's block, or whatever. It's blocks or time based off of if it's below or over this number. There we go.
So cannot lift policies that have height lock and time lock combination.
So they're catching it at this point. I thought they said something, but maybe they're just like giving warnings, but they'll still let you compile it. Maybe that's what it was.
I'm not sure. It's not compiling now for policy. But yeah, it's there's a lot of like weird things like that. This one is actually one that can like freeze funds, because look at this. Like this branch is now not spendable.
Yeah.
But ones like malleability, you can still spend. Just somebody can like denial of like. I don't really know the full extent of why it's a problem. I also think there's like, I don't know. I think it's stupid. So,
well, I mean, this highlights, as long as we're catching it, why something like Manuscript might be useful, because then we can like prove the correctness of it, right? If we're using it properly.
Yeah, in theory, in practice, like, yeah, I don't know if there's like effort for that. So. But that's Manuscript. Does anybody else want, like, do people have this open and like have typed something in? Fun. If you want, I can, maybe I can send, because I don't know, do people know how to get keys? I can send these to Buck, and he can, or I'll put them on the slide. I will put them in this slide. So if people want just some keys, I'll give you another key one too. So if you want to play around with this, you can play around with it. Does anybody have any feelings they want to share? It's really like generally pretty good. Like, I complain a lot because I want things to be like better, but this is like a pretty amazing, accomplishment. It's like, who here like hand wrote Bitcoin script ever? It's like sucks, right? So this is better. I think. Did you end up using the ones that I made for you in Manuscript for the? Yeah. So for James's, one way that you can use this tool is if you're working on like a protocol, you can use it just as like an assistant, and you can use it to like generate the better fragments of the script, and then not use this actual tooling when you're putting it in the code. So for James's like simple vault thing, I just like hand put in the logical equivalent of the scripts that he wanted, and then like I sent him the fragment, but he hasn't integrated it yet, which is fine. Like I'm not putting you on the spot. I'm just noting that you could use it in this way, and then it would be better because then all of the scripts that you're using in I'm not putting you on the spot, but like all the scripts that are in your program or whatever would be compatible with other types of Manuscript analysis tools, which is really nice because then like if there's like a Manuscript PSPT signer or a PSPT finalizer, like you could use all the other tools to like accomplish those without having to like roll your own for everything. Whereas if you write your own custom scripts, you're like kind of on your own for all that stuff. Yeah, that too. I think it was a little bit smaller, so a couple bytes. I don't have that available. It's probably somewhere, but maybe I have it. 1 second. Yeah, I don't have it handy, so I'm sorry. I think I just like wrote it into like a test case and like then like compiled and ran that test and then had it printed out and then I deleted it. So, but hey, you know what? Actually, why don't we do it live? That's also an option. So I will copy this to treat it as a hash because it should be the right length. And do you remember what the what the scripts are, James, for the thing? Mm-hmm. I think it was this, if I recall. It was either, because it's bare script, so no taproot where you just put it in its own branch. It was like either transaction template with like some hash, and I just put in garbage data because I don't really care, or PKA and after some time, I think is the fragment that was needed. And that's after something that's just a plain CTV. And then that generates this thing, which is key checksig, not if,
Right.
template verify, not before, drop op1. And then this is a quirk of like some stuff that is stupid about Manuscript that needs to be patched at some point, but is like a issue in the type system that requires you to have this extra drop in op1 that we can probably fix at some point. And then else 64, which is 100, check sequence verify, end if. And this is not something you'd come up with by yourself. Like, it's sort of weird. Manuscript is like brute forcing it in a clever way internally in the policy compiler. And it's like smaller than the way that you'd write it by hand. So did I do the right thing on the input? Yeah. Cool. Does anybody have any ideas of how they might use Manuscript in like something they're doing now that they previously didn't think about? Wilmer, I know you said you were thinking about Manuscript. Does it work for what you want it or no?
I'm just not sure if it can handle like the arbitrary script validation. Does that make sense?
Yeah, probably not.
Has anyone published all the lightning contracts in Manuscript policy?
Well, I think that they all are generated by Manuscript now. I'm not sure about that, but I know that like they found that like Manuscript generated more efficient HTLCs than they were using before. So that's kind of a big win for the project. Sapio is definitely like one of the more aggressive users of Manuscript because, and this was an issue I had early on in my adoption of Manuscript, was I was telling them, hey, I'm going to use this as like automated tooling. They're going, you're doing what? I'm like, I'm using it as automated tooling. And I think that ruffled some feathers because then I came with like a weird list of requests of like, hey, let's make this deterministic. And they're like, why wouldn't you just be outputting and saving every script coming out of this thing? I'm like, because I'm building deterministic tooling, so switch everything to like B-tree maps instead of hash maps. And people are going, I don't see that. But now I think people have come around to seeing what Sapio is doing and why Manuscript should be like considered, like tooling you'd rely on. But there's still some things that people get upset about, like policy not having like, policy does a lot of optimizing. And I kind of think it makes sense for Sapio's use case for policy to like not do as much optimizing, but be more straightforward. So I don't know. Like what I want is something that's basically in between an optimizing compiler, which is what policy is today, and something that just in a very straightforward way figures out how to make the damn Manuscript flags combine together correctly, which is itself like a difficult thing that people can't do by themselves. So sort of an in-between issue.
Trying to think about, projects where this might be useful. I could see using this in something like Caravan right now, which is basically just very simple. You dictate, like, I am doing M of N multisig wallet, here's an XPub, and now create my multisig wallet. I think it'd be nice to have like wallets that can speak lock times. And if you have like the keys that you want involved, and then you create the policies that define that, you can then create the addresses that will do that, and also have something to export to recover it later on.
Yeah, that sounds like a great use case. Like definitely if you have any infrastructure deployed that uses any sort of like handwritten script, like you should try throwing the policy that you want at this and seeing if you get something better, because the odds are like decently high if it's at all sophisticated.
And I think one of the things that I really liked about the Sapio Studio is basically like a wallet, is having in your wallet also the list of contracts. And if you have, so in Caravan, you just give up the XPubs, and then you have just like a simple multisig wallet. You can you can have contracts based off of those keys as well. And it'd be cool to have like those contracts, maybe some time locks involved in that wallet, as well as just plain multisig, maybe eventually a CTV type of vault as well.
Yeah, sure. Okay. So who here would actually like to get Sapio running on their computer who has not done so already? Okay. So one person. Okay. Oh, well, yeah, I guess who has already done so? Had Sapio running? Okay. Well, I think we're going to focus on that maybe, but I guess if there's not like that much interest in getting Sapio running, we can do something else. What are people interested in? Cookies? I don't think we have any. Oh, there are cookies. Oh, are there kosher or Passover cookies? Torturing me. Yeah, I mean, we've got like an hour left. Like, you want to just have like more open discussion. Like, we could try and maybe like be more of a circle than like a lecture. It is pretty cool like to run Sapio, but I get that it's like a big scary binary written by this weird guy. So like, I don't hate you if you don't want to run it, but it would enable you to do cool contracts. We could look at some other contracts in Sapio. We could like look at the code. People interested in that? Yeah. Okay. So one of the things that I had set up for today was an exercise. And the exercise that I set up was to take the James O'Byrne vault and turn it into a recursive version. And so I did that early this morning. And let me see if I have it loaded right now. Otherwise, I'll need to make a new instance of it. I think it was this one. Yeah, check that out. What do you guys think about that contract? So we've been showing you all these simple ones, but now you're in the big leagues of complicated contracts. And here's where it gets really cool. Let's look at that timing simulator. I need more time. So in this one, it terminates, let's make this really big. In this one, it terminates after 5 steps. So, yeah, like what's going on here? If you zoom in, what you'll notice, and this one has, like, I've relayed parts of it to the network, but what you'll see is like this is the same thing as the James O'Byrne vault, but it's just like there's now like a flow to it. And what's going on with that flow is that at each step, I have the opportunity to cancel the remaining steps of that vault. And then I can do a step, and right now this one's conflicted because I broadcast the transaction to like stop it, but that creates one vault with 0.01 Bitcoin and then passes the rest onto, and I'll play with the time locks here so you can see what's going on, passes the rest onto something that I can either send all the way back into my emergency backup, or after some amount of time, I can keep on rolling out and create a new instance of the vault with a new recursive step that I have to wait another 1,000 blocks to withdraw a little bit of coin. And so this is kind of cool, right? Do people get what's going on here? This is like a recursive vault that like withdraws into a sub vault that you then have to like decide what you want with. Does that make sense to people why you might want that? Does anybody like, I don't want that? Okay, so people want it. And what I think is cool about this exercise is I wanted to, I made it for you guys. It's probably ambitious to get through it today, but I wanted I took 15 minutes from like having the James vault to like having this. So what did I have to do that? So this is the code that was like already written for the James vault. It kind of ends here. And what I did was I said, now I want to define a recursive James vault. And I'm going to define it by saying, 1, I have the parameters for what a James vault looks like. All right, got to start with that. I'm going to declare a number of times I want this contract to happen. I chose the number, the one you saw, 5. I'm going to do an amount per step. So how much coin should get locked up per hop of this thing. I have a fees per step. And then I've got a timeout per step. And then what I did was I said, all right, now I've got the backbone of it. And I defined recursive James as having, at first I did one option. I just did next. And then I did backup later. But let's start with next. All that next does is you can see it's a very simple, this is why it took me only 15 minutes to get this done. It's a very simple thing. It says template, set, is this big enough or should I make it bigger? Okay, let me, oh, yeah. So then I said, all right, next, and I'm going to do a template. I'm going to set a sequence for the timeout that I said, which was, in this case, 1,000 blocks. Then I'm going to send the, I'm going to spend the amount for the fee, and then I'm going to add an output with the amount per step that goes into the James vault. So that creates a new instance of the James vault at every step. And then if the number of times remaining is 1, that's all I'm going to have. If the number of times remaining is greater than 1, then I'm going to make a recursive James vault with the amount that needs to be left over and 1 less time available. And so that will roll out over a number of steps. And so that was what I started with. And then I realized that it would be nice if I could cancel the rest of the flow. So I could do this backup option. And so for that, all I did was I literally copied all of the code from backup from the earlier James vault thing. And the only modification I had to make from it was wherever I say self.backup, down here I say self.v because it's the James vault version. And I just copied the same code from that because it's the same sort of thing I want, which is send the rest of whatever is remaining to my emergency backup procedure. And then declared, and that was it. And it worked, kind of first shot out the gate. You might add like a CPFP or something to it if you wanted to do that as well. And so then that gave me this, and this is kind of cool. In the example I have here, I played it so that I sent the funds back into the deep cold, emergency vault case. But I think this kind of underscores how composable and easy it is to work with. Before I showed you this, if I told you oh yeah, we can take this James vault and make a recursive version of it, that would be a weeks long thing. This is literally a 15-minute patch to add a pretty sophisticated thing. When James made this, I feel kind of bad. like he did this to be like the simplest thing. It's like, oh, we don't need the complexity. And now I'm like, well, here's how you add the complexity back. But it's kind of cool because remember we talked about earlier, like that you might spend a lot of time building a component and somebody else that you work with might spend kind of like React. Yeah, you spend a lot of time making a component and then somebody makes an application that uses that component. And what's cool is that like let's say like James like really like let's say he knocks it out of the park and he's like, check out this cool James vault I built and I wrote all these simps for it and it integrates with like every piece of like everywhere in our infrastructure, most awesome component ever, component of the year. And then you're like, it's cool, but I want a recursive one. Like you can just plug it in and then all of that other infrastructure should integrate automatically. So it's kind of that composability property is going to be really big, I think, for people who want to, rapidly prototype and iterate and prove out that parts of their stack are like also for like testing. You can test any one of these individual modules by itself. And then that like, maybe the backbone needs its own test, but like, what parts of it are well covered by your testing regime and things like that. And the reality is like things like that, like testing, like aren't super well done in Sapio right now, but it's sort of, it's getting there. There's a lot of work to be done, but it's kind of a cool composable framework for these things. And then it's just an example of like, I don't know, like, this might not be the most convincing use case because you're like, this seems like a lot of complexity, but imagine the thing of like, I want to deposit funds and then withdraw like, 1 coin, a year from my emergency thing, and that's my budget. Like this would let you set up this automatic flow and it guarantees the serialization of that flow so that it's not like, all your coins come online at once and you've got to fight off all the dragons. It's like you got one vault that you're managing and that can be really nice. So yeah, anyways, I think that's pretty fun. I'm not gonna load as many up in Sapio, but just in terms of what's in like the repo, it's really worth poking around because there's a couple different directories that are interesting. Well, I guess first, does anybody have any like questions on like this recursive vault version? Does anybody want to see anything else about that? Wilmer.
I have a kind of related question. So could you have something similar to this recursive vault pattern, but instead, like let's say you do a withdrawal from a vault and then the change output, the change from like that withdrawal is like goes back to like that same vault address?
Yeah, that's a good question. So the thing that I think is a little bit like the more general question is like, can I have a vault with like a dynamic spending limit where I can withdraw less than the amount pre-committed to? So that's kind of the general question, right?
Yeah.
From a security perspective, there's not really much difference from the ability to withdraw less and withdrawing the entire amount and then sending the rest back. Does that make sense? Mm-hmm. Like if I have the ability to withdraw like a certain amount of coin and I choose not to do that, that's like an attacker who got that ability, they would just take the maximum amount at that stage anyways. Does that make sense? So the question basically boils down to, is there a way that you can send the coins back into the vault after you take them out? Or can you send like a subset of those coins back into the vault and keep some out? Does that make sense?
Yeah.
You can do some things like this. There are some issues with it, but it's a little bit subtle, like what you'd have to do for it to be correct. It's not like the most obvious way of doing it, but you can kind of chain vaults together by having like taking advantage of that thing where you commit to the script sigs. You could commit to a specific like chaining P2SH output that is just an op true with assault or something like that. And then that would sequence the things kind of, but there's a little bit of like, like you need to use your application correctly in that case. So I'm not sure that's like the most advisable thing to do. You also could just like create a new vault that has a date that's like after this thing's supposed to be over. So that would also be another option. The other thing that I would say is like withdraw the money and then don't initiate the next step because it's all relative time lock based until you actually want the funds. And that's probably usually good enough for most users. I think that's something that I really learned from like James is that like I was getting a lot of pressure from the community of like, you can't do the ultimate absolute flexible dynamo vault with CTV, therefore it's no good. People really need these really, really flexible vaults. And I think that is probably just like not true for getting product market fit. People need something that guarantees that they have flow and control over their funds and that they don't get like completely stolen with no notice. Anything above that is a very marginal benefit. Is I think probably close to the ground truth, especially given that you can have something that like chunks it out over time as well, not just like a single, unvault operation. But maybe that's wrong, and like certainly if you gave me the choice of which one to have, I'd want the more flexible one. But I think it's a question of like, are we going to be able to deploy infrastructure people would want to use for a long time? And the answer is probably yes. So
Cool. Thank you.
And yeah, I hope that answers. Some of these things are like whiteboard questions. Like I can show you like how it chains together. It's like not something Sapio can support out the gate because I think it's like low priority, but it's possible. Yeah. Any other questions? So what I was going to say is like, there's two directories that are worth kind of like thumbing through here. There's plugin example, which has like code that you can run. And like they get compiled to WASM modules and it's pretty cool. There's like fun stuff in there. You can do it all from the GUI. And then there's also the Sapio contrib directory, which has things that like are maybe like I don't quite know how to hook up into a plugin yet. And in the contrib one, the most fun directory, well, actually they're all a lot of fun. So I take that back, but there's a derivatives directory, which is a lot of fun. And there's like all sorts of like weird DeFi primitives in there. The one that people probably care about the most, even though I think the others are actually maybe like more interesting in some respects, is DLCs. And so here is a specification for Lloyd Fournier's discrete log contract concept using CTV. And the implementation of discrete log contracts under that model is like, it's 260 lines, minus like a little bit of just like boilerplate stuff of Rust, and you get like a functional discrete log contract. That's a functional discrete log contract that you could like nest inside of a vault or do whatever because it's a Sapio composable thing. So it's like pretty kick-ass, I think. And the meat of the logic, like you would need to like read his blog post to understand, because honestly I implemented it and I don't really understand it. I just like followed like what he said it should be the thing. But you have this, and like the way that I defined it, like half the code of this thing is just like also then defining some like standard curves that you might want to trade your discrete log contracts under. So I defined something where you have like a linear positive like price function, and then you get some return payoff on that. One I have like geometric positive and like sigmoid, and then to do is like a custom mini calc language where you can specify any arbitrary piecewise curve of a composition of these things or something like that. But it's really pretty cool. Like you get pretty much like best in class discrete log contract stuff. And I mean, obviously like the people who actually work on discrete log contracts are going to hate me for saying that, maybe. Okay. But like you get that in like, the actual meat of this is like 100 lines of code of like the actual discrete log contract thing, and you get something that works with an entire GUI application. Like that's kind of nuts.
Is there anybody here who doesn't know what a DLC is and would like Jeremy to explain that?
Oh,
Buck
okay.
And me.
Okay. So why don't we just look at this code? Because the code shows what it is. So
First, real quick, you said that this was not ready to be a plugin, but it's just a trip. Like,
yeah.
Why is this not a plugin? Just contrib? What missing?
It needs more simps.
Okay.
So the simps that this would require in order to operate correctly is kind of up here at the start. Is discrete log contracts have a set of like oracles that provide a price feed to you, and I don't really know how to like put that information in. And so you would want some sort of way of telling Sapio Studio maybe, hey, please ping these servers and request from them this information. What's nice about how I've defined some of these things is that like I've defined an abstract interface for an Oracle where it's like DLC Oracle for basic Oracle, and I mean it says unimplemented, but it's like there's this notion of like an Oracle is something that can give you an R value for a specific event and an X value for the Oracle's identity. And if you can do those two things, like what's one way of doing it? Well, we've got a basic Oracle, which takes a URL and a like key that it caches. Otherwise, it resolves it maybe through like DNS or something, and TLS like pings the server and asks for the key. And then you would have some logic here that would have to but like in WASM, you can't do this. So there need to be some support infrastructure for letting you ping out to get this data, and then it breaks the determinism of this contract because they can return to you arbitrary other stuff. But once you have that figured out of like how you would be able to contact one of these servers to get the data that you want and get it so that you cache the first time you ping this server, which is what you would want. You'd say, do this, but then write it to a cache. So if I run it again, I don't actually ping the server again. I just use the values that I cached the first time I ran it. Then you can construct a DLC. And what a DLC is it is a bet contract that says, based on some values that some people are going to sign, please split a pot of Satoshis with me and a counterparty or a set of counterparties. And that's where, like, when I say this is best in class, I really mean it, because this allows you to do arbitrary sets of oracles, and it allows you to resolve contracts with an arbitrary set of parties. I believe, maybe Ben can correct me if I'm wrong, but like the DLC specs don't support multi-party right now, right? It does? Okay. So this supports multi-oracle and multi-party resolutions. So if you find a set of people who are willing to pay into this contract, you can resolve with any curve that you want for any number of people, which is pretty cool. So you can like be like, if the price of corn is this, these 10 people split the funds in this way. And a simple way to think of this would be you could have two sides, side A, side B, but you really could have like a complete multivariate manifold of like how much money people are getting, as long as it adds up to the pool that was put in originally. That's something that's just like crazy. Like, it's really cool. And the way that it works is relatively simple. Like, there's a case where everybody cooperates and agrees on what the outcome should be, which is maybe like the happy case. And there's a payout case where essentially you have a way of reassembling a key out of what the oracles release. And then if they release the proper keys, you can like put them into a satisfier on the outside of this. And then it just does like a normal like payout thing where whatever the payout matrix is that you specify for each outcome, it will ascribe the correct amount to all the participants in that DLC. And then what I have down here on the split functions, like I think these are only for, actually no, I defined these split functions for more than one people, I think. But then there's like some tests you can see as well where this is actually happening. And we have like a cached oracle that does this, and it makes some DLC. I don't know if that's like the best presentation, but if you have your text editor open, you can like scroll through it and you can see exactly how it's working and stuff. And there's mailing list posts about it. But to implement this, like it took me like an hour. And I think that sort of like rapid iteration, obviously like I'm really familiar with these tools. But like anybody could train up to have that competency in the tools and ability to also like modify them if it's not doing exactly what you want. And like I think that's great. Like I don't know. Like I think the more rapid iteration we can have, like for something like DLCs, there's just this huge question of like product market fit. Like what do DLCs need to do or be in order to like actually create liquid markets? And if your turnaround time on modifications is like measured in like weeks, like kind of like NGMI. But if your turnaround time is, hey, we can like spin up really quickly like a playground and like do a bunch of different DLCs in the span of like a weekend, like then maybe you can actually like find things that people want like a lot more rapidly. And that I think is really good. So it's a big win.
Something like this too would be super useful for
like stablecoin, yeah, because you can have like a DLC stablecoin thing. That I actually have had in Sapio for like a very long time. A risk reversal contract, which has a very pretty picture, and that is not using DLCs exactly. It's using a different kind of derivative protocol. But you could also implement this curve, and then you get something similar where you'd say like, look, you now have a Bitcoin interest that's like stabilized against the dollar, and you can embed that inside of like anything you wanted to. Like you could embed it inside of like a non-interactively open Lightning channel, and then you could have a Lightning channel that's like de facto is like opened into a stable coin, and then you would iterate on having that nested stabilized position, and then you can continually update your risk reversals to be matching like a plus or minus 10% price target of wherever the price is moving. So like you can probably like, if for a lot of these things, like and like right now, like I think with DLCs without CTV, the construction time is sort of like a blocker for having it in Lightning that you're routing through, because remaking these I actually don't know, but how long does doing like a DLC take with like two people? What about like 100,000 price points or something like that?
That'd be like 5 seconds or something. So it's still kind of slow. Not enough for routing payments.
Over network or like local on computer?
That'd be like 2.5 seconds each. You know, send it back and forth. So.
Gotcha. Okay, that's not as bad as I thought. But yeah, these things would just be like very instantaneous because they're also like non-interactive. So for a lot of these, you don't even need to like update any of the signatures. Like the address would just be like stable. So because there's no signatures, like when you create one of these, it's just like you compute the thing and there's no like pre-computation required. So you can just keep them static, which is cool. So who likes DLCs? Yay. Have you run this test yet? Because there's like tests you can like run the DLC in. You gotta check it out. Yeah, so I mean, there's like, I don't know, like 20 different things you can check out. There's also like options, which are really cool. So there's like different types of options, including like under collateralized option contracts. That's something that you could do where you could have an option contract over a DLC. And that sounds like a weird thing, but imagine you have a DLC that's like for a 6-month dated thing. And then you could give somebody a 1-week option to pay you a premium to put you into a, or not pay you a premium, they pay you a premium. And then they create a, they have the option to pay you a premium to open a DLC with you by adding collateral into it. So there's kind of like some weird things you can do with that where it might seem like unintuitive, but options over derivatives are actually like pretty lucrative because there's a lot of realizable risk reduction as well as premium paying for that type of stuff. I'm not really an expert in that, but like I know people make a lot of money doing that stuff. So, and make a lot of money like means also create a lot of value. Like I don't know exactly why some of these things trade a lot, but like people are like worried and hedge, and I don't know. You get more of that behavior, more efficient markets. Anything else people want to hear about, or should I like let everybody go? It is let my people go week. Yeah.
If CTV were to be activated, or when it is, or whatever, what would be the first couple things that you would like actually be putting your own money at stake with this? Like how far away are you from like activation, having that stuff like you would be using your money there?
That's a good question. So I think that like probably things like James's vault are like the right thing right now. I mean, I just found a pretty major bug like last night in Sapio. It's a very complicated thing, hasn't had enough eyes on it. Like I think if everybody here spent like a couple hours like going over how the compiler works and like trying to understand it, like that would make me feel pretty good, because I'd be like, okay, like more people have like looked at how, but like I'm the only person who like has like designed this whole thing, and it's pretty complicated. It's got a lot of moving parts. it can be surprising. So that said, like, I remember there was an era where like there was Lightning #reckless, and would I put $100 into any contract that like I'm interested in? I already spend like thousands of hours working on this shit. So like, what's $100? You know? So yeah, I'm definitely going to try stuff out. I think there's a lot of interest in doing like POW swap derivatives, where you can do like a hash rate contract. Definitely, like a lot of miners have expressed to me that they want to be in like a Telegram group where people just like try these things out, and you know, like they really need hash rate derivatives, and this is the only. It's actually for miners, it's fully trustless because they can mine their own executions. So this is something that they've anytime I've talked to a miner, they've been like, we need this.
The POW swap needs CTV.
It doesn't require it, but it's a lot simpler.
I know there have been mailing list posts, I think, about doing like different constructions for hash rate derivatives as well.
Yeah, it's a lot simpler with CTV. It doesn't require it though, but it's just like, yeah. I mean, you can do it like it's also simpler just with Sapio, but like without Sapio, it's like a lot of like intricate things to wire together. It's kind of the part of the issue. So I would do it in Sapio. It doesn't like for me, like I view the risk of like CTV as being like basically close to 0, and the risk of like Sapio as being like close to 1. And I know I'm like advocating that you all use it, but like it's alpha software. I'm like very transparent about that. But like it's good for prototyping right now. And like, would I put a couple $100 into anything? Like, sure. Like I'd love to do like a hodl chicken with anyone, for example. Like it's like you see who wants to take their coins out first. I did like the Bitcoin Hanakia on mainnet with the CTV emulator, for example, like, and that went fine.
So I guess is there, let's say CTV gets activated end of year or whenever, within a month you would put some amount of Bitcoin in a James style vault, and then maybe start like trying to productize the POW swap, because it sounds like there's demand for something like that.
I don't want to go to jail, so I don't know if I want to productize derivatives. But if anybody here would like to help me productize derivatives, who has the relevant not go to jail experience, that's a good conversation. But I probably have a high risk aversion given my previous go to jail experiences. So
that's good. I guess what I'm trying to push on is like, some of the as one flavor of criticism is, well, there's no demand. Well, it's like two of them. It's there's no demand and we're not ready. And so, and I think that was clear as well for Taproot, right? Like we got it out and still nobody is putting their money on it. And so actually, I guess another way to phrase this question is, does it need to be ready for you to be doing some of these things? You're the lead dev of it, right? So, if you're not comfortable yet, then like, is that okay for releasing it? Or is that a goal? Like, I mean, it would be nice if it gets activated and all of a sudden you're protecting your major hodl savings with CTV stuff, within a week after that.
Yeah. So I think like an interesting, point to this is that, I wrote code in 2020 January for vaults in C++. It's basically like I manually wrote a Sapio compiler for some of that. I personally would feel better about that code because I hand wrote every transaction, every script output. I know that everything there was correct.
These are CTV vaults.
CTV vaults. And the issue that I'm bringing up is that like Sapio needs to mature, and that's why I said like CTV risk is like 0, and that's why I said the James vault is also kind of like I know where the bug is, of like the like standardness issue or something, but like I feel like much more okay with that. The nice thing about Sapio is that would I put money into a contract after I review the whole output JSON? Yes, but in terms of like the flow that I have with like Signet right now, where I fire the contract and I figure out where it's broken, like there's still stuff that's broken, but like if I can review all the transactions and I can review all the descriptors, like I don't really have a problem with that, and Sapio lends itself to that. But generally, like I think that this is like what I've been trying to express to people is like, there's a lot of jump and I'll tell you if it's high enough kind of stuff. Where what I've been focused on is getting Sapio like theoretically complete and robust and able to handle a wide variety of things and being able to demonstrate, without requiring too much imagination, how check template verify is a central part of these things. I hadn't interpreted we need this to be actually production ready before we can go with this to be the bar. I think now that it's clear that it's close to the bar, people are going, why don't you have it production ready? And I think it's a fair critique. It's just like it's just not something that's ever really happened before in a Bitcoin thing. And so for me, I'm happy.
So to be clear, I'm asking the question of CTV separate from Sapio, right?
Yeah.
And it sounds like there are scripts, there are CTV scripts that you would be putting your own money in nearly right away after. Yeah.
Yeah. Well, I mean, it's a question of how much. Are people expecting me to put and again, my issue with this isn't with CTV itself. It's just what is would I be putting 100% of my net worth into DLCs anyways? Probably not. So how much money would I put in? I don't know. I'd probably test it out first for a while. When Taproot, how many people put all of their Bitcoin into Taproot addresses? Why not? Okay, sure. So I mean, there's things that have to happen. Yeah. I mean, but for CTV stuff, I feel pretty good about it. So I'm not afraid of any of those things. It's just I'm not going to advocate that anybody even for anything new that you immediately be the early adopter.
I mean, it's kind of you can put your money in a multi-sig, but maybe not one that's written from Manuscript directly.
I mean, I think what's funny is if you put yourself in my shoes from another perspective, the question is do I have skin in the game on this? Am I willing to put skin in the game? And kind of my response would be well, what more skin do you want? My entire professional career will be dead, if I introduce the bug. So I just okay, I can put personal money in. Is $10,000 enough? I'll do a $10,000 thing. Do you want me to put $100,000 in? That feels like an inappropriate amount of money. But if that's what it was required, I guess I can probably figure that out. We have a bounty for 5 Bitcoin. I'm sure people, would be okay, doing that. Or if it's got to be my own money, I'll, hustle to do that. I've spent years of my life on it, so I can figure it out. But I think it's just it's not really clear. It's if the measure is Jeremy needs to put this much of his money into something based on this, I'm just not sure where that argument stops. And I also don't think it's necessarily a good precedent for devs in general of because then you run into a thing where it's now only Big Co X can do this because Big Co X put up that they have $1 million locked up in a on-chain bounty, and you as indie dev didn't do this, and you haven't met this $100 million threshold. Because Bitcoin is $1 trillion asset, you can't spare $100 million. It's I don't have $100 million. So,
I think part of what I
yeah.
was getting is what are some of the use cases that you're really excited about?
Yeah.
And beyond most one of the ones that I like, maybe you can talk about is the delayed lightning channel opening stuff.
Yeah.
I think there's a really, really practical, say, retail use.
Absolutely. Yeah.
Yeah, just to double, that is kind of what I was getting at. Is more there was a lot of people that they wanted SegWit enabled because they wanted to start using Lightning for certain things and just start building it, and less are you willing to put your money where your mouth is? Because I think that's been true because you probably could have made a lot more money working at a FANG and actually had a vacation by now, but instead so obviously you've put something at stake, but I just think it's more part of what people are wondering is do we want this? Is it necessary? And I think thinking about it in a positive light, what are you excited to start having people using with live money is I mean I do think the vaults, I see that in the context of Unchained. I think there's a lot of really exciting value that we could bring to customers if we had stuff like this. And I'm just thinking what from you personally, after you take that vacation, what are the things that you're going to be working on?
Yeah. So I think that vaults are definitely there as this is something that is a really, really big win. And the personal use case story around going on vacation and not worrying about what happens to your single sig at home funds is a pretty good one. So not that I have any single sig at home funds because multi-sig everything and they're ripped up and geosharded, whatever the thing is you're supposed to do. And so that is one that's immediately a good thing to do. I think what's tricky about vaults is that from like a security perspective, like doing like a couple like vaults are something that you're supposed to like feel comfortable with like your whole stack on. And even if CTV is fine, like in the vault software itself, there may be other issues. And so I wouldn't recommend anybody like be like early adopter of their whole stack, but like test it out, like do it many times, like study it, and that's good. Whereas for like something like Lightning, it's like, maybe, yeah, like you can play around, you can have an optional like open up non-interactive Lightning channels, and that's when I would, throw money at and try out a bunch. I think that solves like a lot of like cool problems for Lightning. The other ones I'm excited about, like DLCs, PAL swaps, and what part of what I'm hoping with Sapio is just that like there'll be more tools for coordinating, doing these things with other people. I'm also really excited about DAOs. That doesn't really even require CTV, and that's something that's also sort of central. Is that like the way that I've tried to position myself is to inject myself with like a big dose of neutrality, where I've been very focused on like DAOs as a use case for my stuff, because it's something that makes me neutral to whether or not CTV goes through. Because it's a big thing that's a problem is if I'm like, DLCs with CTV are supercharged, I'm going to start a DLC company that depends on this. People will block CTV progress for that reason because they'll view it as I'm promoting it for a profit incentive. So I really don't want to, and that's also why I've not focused on like vaults as a thing, because I do think that there's ways to make money off of, like, I think making money is a good thing, but there are ways to make money off of CTV existing. But if I'm connected to that profit funnel, like then I disqualify CTV entirely. So like, it's just one of these community dynamics where like, I don't really know how to square that away. Like, but I, don't, like, people already give me enough shit for like whatever they interpret my like motivations to be. Like, I very much want to have like no motivation. I'm a demotivational speaker. And like, I don't know, like there's a lot of things I am excited about, but like, that's just sort of like the tension of like, where I'm like, I'm trying to focus on like Sapio as like a good thing no matter what. And for CTV, I think it's like, I'm excited for like what vault companies will build. I'm excited for what Lightning will build. And I'm excited also to like work on like the next step of like evolution, because ultimately that's where I see myself as like, I'm a protocol developer. And like, once I ship this, like, I'm confident that people in other parts of the stack will be able to use the tools that I've worked on and the technology. And like, I want to get like sponsors done. Like, that's where my head's at, is like, that's what I'm excited, is like beginning that process. Maybe I need a longer vacation to actually begin a full software process. But like, to me, I'm like, this is like now like, the thing that like is going to, solve some of the other issues in some of these, Lightning or, other protocols. But I mean, I want to try all these things. I also want to see what people come up with and just like try their stuff too. So I don't know. It's probably not the most useful answer. Yeah. Yes. Here is a coin pool in Sapio. So actually, I have a plugin version of that one. One second.
There's a mailing list post for it. It's been built in Sapio. I kind of feel like.
Yeah. So originally, like the names of this stuff is kind of annoying because like they all just got like generic, and people are like, oh no, your thing is join pool, my thing is coin pool. I'm like, can we just like, can you name yours like jacuzzi and I'll name mine hot tub or something, and then like we're good? Because like the generic names, like I don't know, it's like I'm not gonna remember that kind of stuff. But for a coin pool or payment pool, like here is an implementation of one that. I think I had to remove the plugin component of it because it had like a way that you can link it to dynamic plugins, but that was broken when I updated part of it. But this stuff like works. The thing that's interesting about payment pools is that like as a concept, they're really simple, and you actually don't need any covenants to do them. You just need like tooling to enforce a multi-sig covenant. Where covenants help is in the bootstrapping in initial creation of it, where you can make it in a way that requires less interactive signing, and you can also create one on behalf of people. So for example, an exchange business could pay out to its customers, and it could match them into payment pools. And then it could say, you should now coordinate with these other people who are like good customers who will coordinate with you for your, ongoing business. So that stuff is really great. And I'm excited about like where that can go. The thing that I think has like really been like toxic in the payment pool space is that people have like really fixated on niche properties that require much more sophisticated soft forks, when the core concept of a payment pool doesn't even require a fucking soft fork. So it's like, why are we spending all this time talking? Like one of them that came out, like I don't want to name names. Like I like all the people. It's like they're like, oh yeah, we couldn't figure this out, so we have a hard fork as a part of our proposal. And I'm just like, dudes, like you can do something. And like they harshed my stuff on like a blog post. So that's okay. They're like, we don't think this one's interesting. And I'm like, but it works today without a soft fork, and it's a massive improvement to scalability and privacy. And also in terms of privacy, the ones that you can build today or with CTV like are better for privacy than the other payment pools. So that's why I've not really been able to figure out like what people's prioritization is around this stuff. To me, it feels a lot like people care a lot about the aesthetic of the payment pool more so than about the engineering concern of like how much privacy, how much scalability is this providing. Yeah. So broad stroke is single UTXO where any person can be both. Well, actually, some of them don't even meet this design. So it is a single UTXO where any person is able to remove themselves from it if they are no longer enjoying their experience being in the pool. Otherwise, you are able to, as a group, do a multi-sig operation to line up a series of payouts and payments in or balance transfers within the pool. And you should also be able to have channels nested inside of that. And this is, if you look in the coin pool folder, or not folder, like the Sapio contrib, what you can see is an implementation of this where the coin pool has a then branch which bisects the pool in half, and it bisects until there's an individual who comes out of it. Otherwise, you have an all approve guard where everybody can do something, and then you can vote as a collective, because everybody has to approve on what the next pool should be. And when you do the updates, there's sort of like a protocol for like reassessing what the balances should be that everybody agrees on, like what's the new pool that we're moving the funds into, and what's the allocation of assets within that pool. It's similar as well also to the I haven't published it, but like there's code for like DAO related stuff. It's kind of the same concept of being able to split out and things, and that alone has like enormous scalability and privacy gains. But other people working on the space of it exclude this as a valid design for various reasons that are like, I can explain them to you. I don't think they're like good reasons, but they're reasons that people have. So I don't know if that's helpful, but like I'm excited about that. Like a lot of these things are social though. Like who wants to be the only person running a Lightning node? Like I would be excited if I could find people to do DAOs or payment pools or these things with, or non-interactive channels, but vaults are sort of very self-sovereign. You can get the benefit even if only you do it.
So just to clarify, this pool design for individuals that exit on-chain is basically a logarithmic number of transactions.
Correct. The other designs tend to be a constant number of logarithmic sized transactions. So there's also an issue, which is in some of the designs, if one person becomes dead, they require everybody who's not dead to exit the pool, which means that for one person going offline, you need to do n log n chain work unless you support forced evictions. And in the CTV one, it's symmetric. It's always, if you want to leave, it's log n. If somebody wants to kick you out, it's log n. So. And it has better privacy properties because it has substructural privacy, where the recursive structure of it, you don't need to share information to the entire pool, whereas the other ones have a flat org structure where everybody needs to know the balances of everybody else in the pool. So sort of the privacy properties are better as well. And if you count the bytes, the CTV style one is actually like superior for the everyone exits case by about 7-fold compared to TLove. So it's like, that's why I don't really get what the issue is. It's like kind of seems to be better than like T-Love one. Yeah, tap, leaf, update, verify. But they're like, the first withdrawal is about twice as big. It's 400 versus 750 bytes. The second one, is much smaller. Yeah, the first one is a little bit worse, but it amortizes. So, yeah.
Like that, and who would be the person that's leaving that you can have to pay the fees, right?
Basically, yeah. It's a logarithmic number of people pay a constant amount of the cost or something like that. I don't know exactly, but it's not that bad.
I guess that's the other advantage of the CTV one, right? Is that you, like all those other branches, you don't have to. You're committed to the future state, so you don't actually have to like lock them in on chain.
Yeah.
So you can wait for cheaper fees as well, so you can save even.
Yeah, I mean, these things aren't time sensitive generally, and the other big benefit is in one of the other designs, they only have evictions in the case where you have interactivity. And so to me, it doesn't really make sense because like having interactivity means that these things are like very hard to actually set up because you can't set them up on behalf of other people. So you can't have like a liquidity provider who like sets up a payment pool that they're going to operate with like a group.
But that was the other advantage of the CTV DLC too, right? That you could have non-interactive.
Yep. And you can have DLCs in payment pools. And you can arbitrarily nest whatever protocols. You can have payment pools where if you get evicted, it goes into a vault for you, which is I think a nice property because if you're offline, like you might want it to go into like something that's like a more structured backup. But otherwise you get access to the funds as like by everybody no bidding the contract. So there's some cool, like cool design space for these things. Like the composability to me is really exciting.
So we can keep going for a little bit, but I just want to make a little announcement that Unchained via Druve is inviting everybody here to do kind of post-event hangout and drinks at the, Firehouse Lounge just around the corner.
Awesome.
So, and then we can all get dinner as well and keep the conversations going. So.
Oh, yeah, I guess will I be able to secretly, by you emailing everybody, email everyone after the event?
Yeah, I did not coordinate like communication very well, but we can get messages out there for sure.
Cool. Yeah, I'll just follow up with like some links and asks.
Yeah.
Does anyone sorry if I'm like a little bit, jaded energy right now, I'm tired, but does anybody have any, like burning questions or, anything you want to grill me on? Like, I hope you can tell I like really try to, like be open for like feedback and hearing that like I'm like not doing something well. So like, please tell me, like I will take it to heart and try and do better.
We love you, Jeremy.
Love you too.
What is like the craziest, weirdest, fun thing that you would do if you had every covenant enabled possible? Your fun project.
Yeah. Well, I mean, I think that like if you had every covenant like possible, like you would just kind of have like the Ethereum virtual machine. So like you could do those things on Ethereum already. So I'm not like, but like I think maybe with like within a limited set of those things, I think what I'm really excited about is having like the zero knowledge proof verifying stuff and having the conjunction of that with like a payment pool where you can have a payment pool where all you're signing off on state transitions is like, I have verified that like I can get my money out, but I'm also enforcing all the rules for everybody else. Like to me, that's really cool because then you can have like, sort of like little groups of people who have like very sophisticated smart contracts running in their own like secret sidechain type thing. And that's something that, some people are working on the, like Starkware folks. But I think that's like quite a ways out. But I really like Uniswap. That's like one that like I'm excited for like the BitMatrix stuff. I think that like Uniswap is probably one of my favorite smart contracts in like the space of like things because I think it just completely routes the traditional IPO process. And I think what we'll see like in a very like long run is like IPOs stop being a thing, and then like incentivized market making that's decentralized become like a big deal. And I think that that's like a very good idea. And will take a little bit of time to like percolate to the markets. And like it's something that Bitcoin, like I don't see a direct path to that other than like, well, BitMatrix is like kind of doing it, but like it's a little bit messy. So that would be my favorite one, kind of starting to happen. Have you looked at BitMatrix at all?
No.
Worth checking out. I mean, I like Barack a lot, so.
That wasn't meant to be allowed.
Yeah.
So just tie this. Yeah, there you go. So for me, I'm not an engineer. For everybody that's still in the room, for me to tie this together, bit swap, Uniswap, but directly on the Bitcoin protocol stack. What are the missing pieces that, in your estimation, to get there, or something like it?
So the automated market maker stuff, like there's a lot of structural reasons why they're actually really efficient. At most times they're inefficient compared to traditional markets, but they're much more strongly available, which is why they're interesting. And so a lot of the things that people talk about in terms of like, oh, what about atomic swaps? Like if we had tokens, we can do atomic swaps. Like that liquidity can dry up really quickly during like a flash crash, for example, or people just like take their market making off, and then they won't trade with you. But where the automated market makers really shine is that it's sort of like always on infrastructure. And so the ability to trade against them, like, even during big events, I think is kind of cool for like what's the systematic like infrastructure improvements that like help society. But to have them in Bitcoin, like the asset protocols, and I think Taro is like a huge step up, but like even for Taro, it seems like a really difficult thing because Bitcoin contracts don't really have a notion of like state that they're maintaining. And they require like individuals, maybe like under a multi-sig or something, that are driving that process forward. So BitMatrix is like very exciting, and their revamp of their protocol is like pretty well done. So that design I think is pretty like promising and exciting. I just think it's like very, very, very complicated way of doing something that in Ethereum is like a very, very simple implementation. So I'm not sure exactly how in the UTXO model if we'll be able to get that sort of nicety of like really, really simple thing that has really, really nice behavior. And that's just something that, I don't really have a pathway to that type of thing. So like, I don't have the answer. That's a long way of saying I don't have the answer. I just know where the problems are.
And problem is also, 64-bit arithmetics.
Yeah.
And I don't think even simplicity will solve them. So for arithmetic.
Even what will solve that?
Simplicity. So
Oh yeah. I mean, yeah. It won't really solve it.
Last time, speaking with Burak, he said that literally you need 128-bit arithmetics to do pools more than 2 millions of
Yeah, I mean, I like everything they're doing. I just think it's a very, very tough problem they're trying to solve. And I'm like, there's a really good explainer video Brock put out that like, I didn't really fully get the protocol until I watched it. Now I feel like I fully understand how their stuff works. So I would recommend the video he has on his Twitter. But yeah, they need, even from Liquid, they need a little bit more. So it's like, when's that going to come to Bitcoin? Like probably never. I'm interested in doing things in my lifetime. Probably not the most pump up answer, but. Cool. Was there anything else anybody wanted to see or look at or chat about? Otherwise, maybe I'll mic off.
I have
So my cosmic question is, how worried are you about UTXO ownership scalability kind of on the base layer? And do you think that coin pools will ultimately be, in some incarnation, a solution to that?
Yeah, that's a fun one. I think what might so people propose crazy things like you're gonna have 5,000 people in a payment pool, and I think that's like probably not gonna happen. Coordinating 5,000 people is like really hard. What you might see is you have 5,000 people in a payment pool that is like run by 10 people, and maybe that's like kind of like this like micro banking infrastructure kind of thing. And then those payment pools can be operating, like have an operating system that's like a Chaumian eCash server. Yeah, but I think that they still would really benefit from like CTV in particular for like the peg in and peg out stuff, and also like the treasury management being done through like things that are a little bit more like vaulted. So it'll be interesting to see like how those things kind of like merge together in the long run. The thing that I think will probably be true is that like people probably will still have like a UTXO per person, but they may have 1/10 of 10 UTXOs. And the availability guarantees and sharing guarantees of having 1/10 of 10 is better than having like one of, or like a portion of one. So I don't think it makes it so that people will just be a part of one payment pool. I think people actually want to be a part of like a good many of them and have their funds split across and have different guarantees across them. And then the availability and signing rate of transactions will also go up. And so I think that that might be the direction where it's not like this model where people have like only like one account that they're managing somewhere. It's like people have a lot of accounts, and then they'll be looking to try to do business in an optimized way by taking advantage of like some sort of hub and spoke like or topology, you know, where you can do swaps between them or something like that. And I am skeptical of this being competitive with Lightning, because I don't think that Lightning is suitable for large volumes. I generally think that Lightning, for example, will not work for things like payroll, whereas like payment pools like might actually be able to work for things like payroll if it's part of your local community. I just think that like if I am an employer and I need to pay 100 employees and I am paying them out of my like revenue, then I will not have the ability to have that collateral locked up beforehand unless I'm in a particular set of businesses like tech, where like labor to profit is like low. But if I'm in like if I'm like a restaurant, like I don't think that most restaurants can lock up enough cash to have the outbound liquidity. And the counterpoint I've heard is that like, oh, well, like most people won't save money. And then I just sort of apply the lens of like, if people can't save money, if most people can't save money, then like, and that's because of a scalability limit, like of some kind, like that seems like the system we're doing is kind of broken, because I think people like should be saving, and that's what people will want to be doing. So it's sort of like contrary of like people won't be spending as quickly as they're earning because they're going to try to be saving. So like I think these things polarize anyways. So that's why I'm skeptical of that. But like I do think that like for like the Venmo use case, like Venmo, like how often do you have to add balance to it? Because it's kind of rebalancing. Like you're taking friends out to dinner as often as they're taking you, and like that kind of that nets out. But then nobody gets their paycheck through Venmo. So. And I hated my roommates when they paid my rent through Venmo. It was big inconvenient. Yeah, it's just hard because like even for like a centralized provider, like if you're providing payroll liquidity over Lightning for like 1 million employees, and then they all get their checks and they're not immediately spending that out, and then you have another 1 million people you have to pay, like where's that money coming from? Like eventually the money has to be coming from like locked up from somewhere. So I just don't think that for these like strongly polar flows, if people are saving, like I don't see how it works. But I see how that could work for payment pools where it's like moving from one account to another in a local economy. But I don't know. I'm a skeptic. Like, you know, like I would have to see it working to believe it, if that makes sense. But yeah, multiple UTXOs per person, all shared. Maybe that works out. But I kind of think like custody is too important. Like the self-custody angle, I don't know how you achieve the best guarantees for that. And I actually think maybe trading off like centralization a little bit for better self-custody guarantees like might be a good trade-off. But I don't know.
You mean this like federated bank type thing? Where you have, you said you have like 10,000 central banks.
I mean, I guess like a thought experiment, like would you make the block size 10 times larger if you could get 10 times more people having really good self-custody? I probably would push that button, except like ignoring hard fork issues, like the amount of centralization of 10 times larger block size versus like, 10 times more self-custody activity. Like, I probably think that's like a good trade-off to make. So I don't know. Obviously, you don't want like 10 gigabyte blocks, but.
Right. And I think that's going to be a routine that we have to go back to exploring at some point.
Yeah.
Because, yeah, clearly there's some room for experimentation there. And like the people who are running nodes now, well, I don't know, that's a whole
Yeah. I mean, I think it's one of the issues is that we have all this like tribal epistemic knowledge that like all Bitcoin, protocol development is done in service of like this idea right now that not everybody will have a UTXO in the future. And if that's like a flawed assumption, we're doing a lot of development in service of like a flawed premise, which is sort of a scary thing because like ex falso quod libet. Out of one falsehood, comes anything. So. I don't know if it's false, but like if it is, it's like, not good that it's kind of like one of these big assumptions.
And if we get to a point where base layer ownership is mostly unattainable, I think it's kind of failed.
It's definitely a concern. Like if you draw it out to the maximum, like if the expected income of a person over the course of their lifetime doesn't pay for one Bitcoin transaction, like something's kind of weird about that. And I think that the systems of like the network is set up to hit that type of point at some point. So it's kind of a weird, like that's a very weird, I guess layers are kind of the solution there, but like layers have like trade-offs. So yeah, I'm not. And that's why like when I talk about like the like what reinforces the like system, like roll-ups are a pretty cool solution for that type of scalability where you probably get better like properties of guaranteeing you have your funds than like maybe Lightning, because it's like everybody in the group has the same guarantee on all of their effectively channels, but you get like proofs that an ability to contest maybe, but contest in like a big batch action of like everybody together. So like maybe that's like a more robust path, and maybe that's where we should be like moving things towards. I don't really know. I don't have like, I can't solve all the problems. So, but yeah, I don't know. I think maybe like it's worth having people who like think about things under these lenses, but like I don't think there's like that much appetite to think about problems like this. So. Yeah. Well, I can stop rambling at y'all. I hope everybody had fun. Did anybody not have fun today? You guys are all champions, and thanks for working through the whole day. And you know where to find me and ask more questions, and I'll have more, if you're tired out now, like tutorial content and ability to get things up and running pretty quickly. That's kind of, one of the targets is getting this stuff really fast and easy to use. So hopefully you'll, be able to try out things yourself kind of soon. Thanks for anybody who traveled in for this too as well.